All right, should we get some? You know what we could do though? Do this, maybe. What we could do. Streamer mode, please. Let's see, where is that one? There we go. Oh, everything is a bit laggy. Laggy and, you know, slow. Let's see, where are we? We can do a little bit of this, maybe? No? Testing? Testing? Testing, 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 testing. All right, there we go. That's one sorted. And now we have to fix this a little bit. Okay. Why is that not working? Properties, please. Okay, that's better. There we go. Right. Okay. And let's do the resizing. Okay. So why is it so loud? I don't know. Let's fix them. Let's do a system upgrade while we're at it, shall we? VLC Lurejet. Okay. Well, you can run in the background. Let's see what I've got here now. I am messing around with this stuff, right? So, oh man, I was keeping these notes on another computer. That's not good. Okay. Anyway. Hello, Enrico. How you doing? Hello, Caleb. How you going? Hello, Dottie. How you doing? No, the audio wasn't wired up. Hello, Root. Hello, Chando. So we are going to go through the layout system a little bit. The thing is, it seemed to work. It shouldn't be working. Okay. I had a sort of a closer look at it, and it doesn't look like it should be working to me. So let's start by seeing what we actually have that is different from what is currently on there now. So we should probably patch a few of these things in. So let's start with that. Yep, that one's fine. You know what? No, I can't do any of that because I rewrote the filters. That's not going to work, right? Gaindle time. Oh, man. Gaindle. Classy. There we go. Whoa. Oh, man. I thought this was some inappropriate images there for a second. I don't know what this is. I'm going to say Octopath Traveler because of the color scheme. Nope. It was not. What else has artwork like this? Man, I never get the JRPG. This looks like Ease, but that doesn't seem to be in here, maybe. Origin? No. I can't even guess the time for this. I have no idea what this is. Tactics. Okay. Reeling. Grand Blue Fantasy. I have no idea what this is. No idea. Let's look at the artwork for a hot second. Afterburner, Sega. Nope. That doesn't even exist. All right. What about Space Harrier? No. Then I don't know what this is. This feels like early 90s Genesis or Master System, right? I thought this was Afterburner. It is not. It's not Afterburner, it's not Space Harrier. I don't know this game. I think I'm right. Time-wise, I could tell from the artwork style roughly where it was, but no, I've not played this, so I don't know. Yeah. Okay, so we don't have a chat on the screen. Last stream was insane, by the way. We don't have a chat on the screen because I now kind of taken the whole thing apart rather than working on a separate branch, which is what I really should have been doing. So everything could have been working, but I was so frustrated with how the layouts were being done and looking at some of these things that I thought, okay, we're gonna have to dig through this thing now. So I'm gonna monologue now for 10 hours. So you better enjoy it, right? But I'm gonna keep my monologue up here instead, right? Right, now you know. Let's go into widgets and let's look at this thing, right? So the way this works right now is that we have two separate steps throughout the process of the layout, right? So step one is going through the fixed layout. We can see this if we go to the runtime, not rand time, cycle. Right, so we first run through all the fixed widgets, then we run through all the floating widgets, right? Oh man, it's warm. Anyway, so in doing this, we're effectively running through the tree twice, which arguably is not a biggie, right? So when we go through the first layout step, right? Okay. So given a tree like this, text, position, text, text, right? We end up with two filters, right? The first one we would have, they would look something like this, right? Fixed would have VStack and float would have nothing because there's no other widgets in the root here, right? And since we do fixed first and then secondary we do floating, we end up creating the VStack as the first step, right? But if we follow this through a little bit, so we're gonna go to the layout module. That's not here. That's here. Maybe a container, not a widget container. What about an element? All right, there we go. So here in the layout, we're gonna ignore this comment here, but these children here will be the children of the VStack, but they don't exist yet, right? They don't exist until we start doing the layout because everything is the third generation, right? Which is why you can map a VStack to something with 1 billion entries and it won't have a performance loss, right? Instead, it will just generate as many widgets as it can show and then stop. There is a caveat to that, of course. Floating widgets don't have size, right? So you're never going to run out of size for a floating widget. You could create, theoretically, an infinite amount of floating widgets, right? Well, practically you're limited to U16 max, but again, that's 65,535, 36 widgets that you are never going to see, right? Either you're going to draw on top of other widgets, so a lot of it wasted, or you're going to run out of screen space, right? It's irrelevant either way. But unfortunately, as it stands, there's not a lot we can do about them. So when we go through each child here, this is going to be our first fixed widget here, right? So this each here will take us into calling layout on children, which is recursive, right? So again, we're going to go through and we're going to do the layout of the fixed widgets. Now, what we should do here is we should break this up. But I haven't even gotten there yet, right? But what's the reason for two passes? Floating and fixed, right? So actually, that's a good question. Why do we need to make it two passes? Fixed widgets will have no size. Well, actually, no, that's not true. That's why. Because fixed widgets do not have a meaningful... Sorry. Floating widgets do not have a meaningful size for the parent. But they do have a meaningful size for themselves. Right? So when we do in the layout... Floating widgets. Remember, the layout has nothing to do with positioning, right? Layout is truly just calculating the size. But yeah, maybe we don't need to do this as a... I'm sure I'm gonna figure out why it is eventually. Okay, but that could be a pretty intrusive change. So there's a lot of things that are happening here when we do a layout. I don't believe that we are looking at floating widgets ever, but if we go to something like the vertical stack is a good place to start. Which is a stack under the hood, which would be that. And layout would be a many layout. So we're going to go through here. And for every layout we do, we're going to call node layout. And that gives us the size. And here, this is where a floating, we're back here again. This is where a floating widget would report 0 size. Which could incidentally result in a different layout. It could be, rather than being changed or unchanged, maybe. Well, now I'm caught on a detail, all right? So let's write a memorable detail down here. And we're going to say that floating widgets might not need to report a size to the parent, okay? Now, if that holds true, then we only need to do one pass. If it doesn't hold true, then we have to make multiple passes, right? So we could add floating here. I guess we add that there as well, right? Now, if we have a floating here, then it would remain unchanged. So this could just be combined with that so far. Now, this code is a little bit dubious, so we should be a little bit cautious here as we go through this. Now, when we perform a layout on the node layout here, what we return here, why is this inside something? So if we have a cache size, that has to report the correct size. Yeah, all right, that's fine. So that's just going to call the parent layout. So something here has to return a size. There is this here, this container layout, and this should be merged with the container at one point, but we're not there yet. Where was I? Container layout, following this too. This is just a reminder that we might not end up calling this thing. So if the layout is changed, but the widget is floating, then it has no impact on the parent, right? So if it is not a floating widget, then we have to return that it's changed, right? But if it is a floating widget, then it is floating, and we have to deal with that. It's not any float. Any floats. Interesting. We might be able to save a layout call here then, Dottie. If this holds true. I do not know. But luckily, I have recently added a test case for this where we are able to write specific tests to ensure certain edge cases are working, right? Yeah, that's fine. This is now compiling. So what we do when we filter our widgets, maybe we stop doing that now in the layout step, right? Which is going to be a little bit awkward to do here. So in our layout filter, this will simply always be all then. As in, we will no longer have a filter. Instead, we will call layout on parents, all right? So before we do that, let's see what it looks like for a widget to have a layout call where the widget itself is floating, i.e. a position widget. Let's go to the default widget for a position, which the position is floating. Is there anything that is returning floating true here? Right. And the position is the only floating widget we have. That's interesting. Good morning, Adrian. All right. Oye, qué calor, no? Right, so floating widget, this is the only thing that does that. And what does this look like for the layout? The placement is only given to self here, but has no discernible meaning, right? We do need a constraint here that is going to be used somewhere. If position relative to parent means calculating a new constraint, no. Position relative to parent means calculating a new constraint based on the position of top left minus the size. See, I don't think this is true. This is saying that a relative widget has a different set of constraints than an absolute widget, right? But why should it? Okay. Let me elaborate a little bit, right? Let's say that this is our vertical stack layout, okay? So our first widget is going to be our text widget. Then we're going to draw our position widget, okay? But we're just going to draw it as a thin line here because it actually has 0 size. And then we have our secondary text widget here, right? Now, according to this thing, this red area here should get a constraint of this, right? It should get a constraint that is matching the remaining space in here, okay? But that doesn't quite make sense, right? Let's get rid of that one. Hello, Wire, how you doing? So it doesn't make sense that the constraint is affected by the children, right? Why should it? And since we have to calculate the layout afterwards, it basically means that floating widgets should have no constraint. Now, here's a question though, because we have decidedly based this, that's not what I was going to say. We have somewhat based this design on Swift UI and what's the other one? Flutter, right? Because there are single pass layouts, okay? So because we've done that, we can actually use those frameworks as references for a lot of things that we do, right? So let's say, what constraints does floating widgets have in Flutter? Maybe they don't. They're constrained by the parent widget, which defines the size. Is this true? Let's go to the source for this. Okay, constraint. The word constraint is not even in here. That's concerning. Okay. Right, let's look at, okay, constraint rules and exceptions. Parent widgets play a crucial role, blah, blah, blah. Let's just search for float. Okay, there's nothing about floating here. Okay, we can ask GPT here, right? Okay, so given point 1, does that mean in a widget where constraint is changed per child as more children consumes the constraint, in a video where constraint is changed per child as more children consumes the constraint, will the constraint for the floating widget be smaller? Okay, I can't be the only one who finds that weird. So a floating widget could be positioned anywhere. So why should its constraint be affected by what else is there? Okay, let's ask the question, right? A floating widget can be placed anywhere within its parent. Sometimes even outside of the parent. So how does it make sense that a floating widget would have a smaller constraint based, or would have a different constraint depending on how many other children the parent widget has? You're correct. Okay, a clear explanation before we actually venture over and have a look at more of these things. its size and position are still influenced by the constraints set by the parent widget. For example, if you use a stack, you can position the floating widget freely, but the stack itself is constrained by its parent. Constraints and layout. The constraint refers to the maximum minimum size the widget can take. When a parent widget lays out its children, provides constraints to each child based on its own size and layout rules. If the parent has a fixed size or is influenced by other children, the constraint for the floating widget will be based on that. Okay, that does seem weird to me, doesn't it? All right. If we pop over to Excalibur here and we doodle this up a little, right? Food. All right, I don't know what this is. That's part of the game project, so we're gonna skip that and this, whatever. Actually, we can work from here, right? So let's make this into an item, right? So this is an item inside some given container, right? Oh. Oh, that's text align, you muppet. Whoops. Undo. So there's no distribute. No, I think we've been through that before, right? Not that it really matters, right? But here we go. So let's say that this is our vertical stack that we have here, okay? The font size is a bit on the small side. Okay, right. Anyway, hopefully that should be readable, right? We have relative and absolute, but relative just means that 0, 0 starts at the top left corner of the thing, right? But so like this, top 0, left 0 would position the object here. Bottom 0, right 0 would position the widget there, right? That has nothing to do with the constraints. That is part of the positioning step once we calculated the size of the parent. So when we go to position a widget, we will know the parent's position and size. So we can calculate, you know, the top left, the bottom right regions, right? Now, here's my confusing part. So if I make a floating widget, this is all the remaining space that we have according to the documentations, right? Come on, let me type in there, please. Oh yeah, ¿qué pasa? All right. Remaining space, right? Now, if we're gonna do a floating widget that were to be if we were to create a pop over something rather, right? It is Maniac. Oh man, I was in the co-working thing again. Yes, not yesterday. That day. In case you had any questions, but you never turned up. I felt stood up. I'm kidding. Well, I was there, but don't feel like you have to. Oh no, that's all good, man. It's all good. So if I want to create a widget, all right. So my question is a little bit like this: why would the constraint be relevant for a floating widget? Now, if we were to say, I guess the question I'm asking really, I wish we had layers in this. The question I'm asking really is, what is the difference between this and this, right? In terms of how big something is, right? Can I bring this? We do have layers, but I don't think it's really that way, right? Why is this any more valid than this? And more importantly, should this take up space in here if it's relative, right? $5.30. Then I've already been awake for a while at $5.30. Buddy, you gotta, if you want to be a successful businessman, you gotta change your game, mate. You gotta up your game here a bit, right? Oh, that's a hideous color. Okay. Yeah, it make more sense. But the point stands, right? It should really be this. So this guy can go. This guy is here now, and how now? Stroke cow. There we go. Nope, that's Phil. There we go. Right. Right. Why is this thing any more valid than this thing? At least this would be consistent. So if I want to put a alignment in here, for instance, it would size itself. Actually, what the hell does alignments do? They are unconstrained as far as I know. Anyway. You're recovering from surgery. Damn, son. I hope everything's all right, though, right? I'm not going to pry, but hopefully it's all good, right? Unless you had rust surgically installed, then I want to hear all about it, right? Throat surgery. So now you have like two, you can do like Mongolian throat singing. Meow. All right. Good in no time. Might be difficult streaming though, but I get it, right? So yeah, so that is my question. Why is this constraint any more valid than this constraint, right? That is a genuine question. So, all right, there are two things to say about that, but also, no, this makes no sense, okay? Let's take a copy of this vertical stack here, and let's move a little bit over to the right here, and paste this in here. And let's pretend that we are going to insert a floating widget here, right? So come here, floaty boy. No, come here, floaty boy. There you go, right? So we're positioning this widget here. We are given the constraints of this remaining space. Everything is fine. But, and that's a big chicken butt, right? What happens if we position this in between something else, right? So if we position it here, then we say, well, here's your remaining space, and it sizes itself accordingly. Remember that floating widgets do not report a size to the parent. That wouldn't make any sense. And even so, if we place it here or lay it out here, but then we place it at 0, 0, so it's up here, should the remaining widgets not be laid out? Or, more importantly, should we end up with something like this, where we are, well, let's say that we don't use up all that space. We use up this much space, right? And then we position you in the top left corner. Is this what you'd expect to see? A big ass gap there? Right? I don't think that makes sense. That doesn't make sense to me. Why would we want a gap there? If we have bounds, they would be the same as the parent. It is floating, that is correct. The green rectangle here is a floaty boy, right? So this is given constraint after two widgets have been laid out, then it positions itself and changes its size and we report the size back to be of this size. So we have room for one more widget here and we place that widget here. But it doesn't make sense because if we place it here, there's a big gap here, right? For no reason whatsoever. We could have placed this here instead. In reality, this item should be placed here, okay? And floating widgets should be placed differently. But since we are saying that we run out of space once we place this item, and or rather once we lay out that item and this item, there is no space for this item, so this item will never be created. Then we end up moving this item up here, and then this item can't move. We should move it up here, and this guy should be here. But because of these arbitrary constraints, that can't happen, right? That is exactly right, Dottie. Floating widgets shouldn't have any size impact on the children, on its siblings in the tree. The floating widgets should be based solely on the root constraint. Yes, that is another question. We're going to get to that one as well. And I think you are right with that. Yes, this is similar. This is partially based on Swift UI, Enrico. Floating widgets could be based on the screen constraint. Okay, and this is where we get to something a little bit weird now, right? If floating widgets are based on screen constraint, and we say use the maximum width and height at your disposal. Let's draw the screen in here, and you're going to see that we're going to end up in somewhat of the same situation, right? This is now the screen. The text is so small, no one can read this, okay? Why are there two things here? Okay, let's not get bogged down on the detail. But this is now the screen. So we're saying that this floaty boy here is given the constraint of the screen, right? So the maximum thing we can draw here is this, right? That's as big as it can be. But you can have negative positions for a floating widget. So if we were to fill this widget with some hideous color, and we place it at somewhere like -10, -10, this is what we'd end up with. That's also weird. I mean, we gotta give it some constraints, and you don't know the position until you are done with the layout. So you can never know the position. You can't do anything with the position at this point, right? You can do whatever you want, Doddy. I have no power over what clips you guys create. Although I guess I could disable clips, but I won't in this case. It should, Pepper. But the question, I guess this is a philosophical question, right? Is this any more weird than giving this widget the constraint of the parent? Right? Is it any more weird to say the constraint is of the screen or the constraint is of the parent? Oh, I don't think it's a problem. This is more of a philosophical conversation at this point, right? CSS must be taken out of this conversation, right? I gotta nip that one in the bud. This should not have an anchor in CSS, even though we can talk about relative and absolute positioning, but that's where the similarities ends in terminology and maybe functionality, right? Having it constrained by the parent makes it relative positioning based on its parent, and it doesn't feel like it's a model window at that point. All right, help me unpack that sentence now. Having it be constrained by the parent, it just means that it can't be larger than the parent constraint. It doesn't feel like it's a model window at that point. the benefit you would have here is that you could possibly give this a size of the parent, right? So you could have a window that pops over the entire parent, and you can show a button on that window. If we don't pass the constraint, then you could never... Now, obviously, if you should center it or not is really down to the positioning. But again, you wouldn't be able to draw with a different background, right? So you wouldn't be able to do this to show something that hides everything of that without relative positioning gain the constraint of the parent. If you want a model centered on the screen, not that you would do that with positioning, but then you would go with absolute positioning, right? Actually, the point is kind of moot, you know? This is not how you would solve this problem. If you want to show a pop over that covers the entire thing, you would use a C stack. So maybe floating widgets simply are unconstrained in their layout. That means that you could never float an alignment, but that's fine. Because you wouldn't. The reason you would use an alignment, you would use that together with a C stack, right? A floating widgets contain more values than non-floating or fixed widgets. That is entirely down to what people put inside of them. In this case, the fixed widget VStack contains 3 widgets, where the floating widget position only contains 1. But that is obviously subject to what people write in. I might have misunderstood the question. But it seems to me that being unconstrained for size is the right thing to do. Now, if we were to go and look at the documentation, I just need to fix this so I can go back to finishing the board, right? If we're going to look at the position elements here, either relative or absolute, left side of the element with an offset of the given value. So this is really misleading, and we need to update this information to reflect the fact that we are talking about the position in absolute, right? This would be an absolute position where the offset is affected by the parent, right? Hello, Zucchini. But that is not what I want to look at. I want to look at the alignment and see what this one says. All of the constraints, I should say. This means it's not recommended to put alignment widget inside an unconstrained widget such as an overflow, alignment except the most one child. And okay, so there's nothing about this on the position that specifies whether this thing is unconstrained or not. So we haven't really made a choice there, except we have here. And I believe at some point this wasn't there. And maybe it shouldn't be like this then. So a position relative to parent means calculating a new constraint based on the position of the top left minus the size. Given a constraint of 10 by 10 and a left of 2 and top 3, it would give a new cell constraint at 8, 7. Well, actually, that's kind of wild. and also doesn't make any sense, right? So maybe it should be constrained to the viewport and that's it. Absolutist, absolutely. I think maybe that is the thing. But there was a reason why this was added in at a later date. Last year at some point. But I think this widget, maybe not. Maybe it makes sense then to just place it as the constraint of the viewport and that's it. So the constraints are that and this. Right. Now this will get a size. Okay. That is also not correct then. So the size shouldn't be based on this. The size should be based on the children in that case, right? And this is how it should be. Can we just make you into a first and then whatever this returns just becomes an okay. Like so. Then this could just become first. Like that. Apparently not. What did I goof up now? We could probably just make this the size then, right? No, that doesn't return the size. That could return the size. If this thing knew about size. No, it can't because this thing does not return the size. So that can't work. But this could work. And what is it that you want? You're returning a result. The function should return that. No, it can't. It's different. Okay, forget about that. We'll get back to that one later. It won't take too much to wrangle that. We'll figure that out later. I am drinking a criminal amount of water here. Okay, so we get the size set by this thing. Why do we have another warning? Because we don't use the constraints anymore. Somewhere else we have. Okay, never mind. We don't have to fix the warnings now. Okay, so doing this means that we could do the layout all in one go, right? Without having to change anything. The only thing we have to change is that all widgets are always included. So our layout effectively has no filter. So then let's go and change that. And see if this works. Well, all the floating widgets have failed to work now, but that seems to be alright. Can we have access to the parent's size here or not? If not, then we do have to decide the size on the constraint. Maybe that's what it is. The reason why we do this, we fix the constraint, is because that's the size that we return, not the constraint for the layout. So these constraints would be the viewport constraint, but the size would be our constraints, regardless of what it is. Wait, where am I now? That's the position, you muppet. It's the layout we want to change. Yeah, that is right. So we do need the constraint here, and that's going to be our size. And then we're going to pass in the viewport constraint here. Like so. Now it doesn't matter what size the children have. Which means we're not converting anything. So the children have the entire viewport, but the parent gets the size of this. Without that, we couldn't position it within the space, the correct space. So I think that is now correct, although we have more warnings than when we started. And the tests are incredibly broken. But they're only broken for the position, I think. Yes. So now we need to go back into our runtime, and what we call a fixed should be an all. And an all can never become anything other than all-inclusive. Okay, and then if this works, then we can simply remove the need for any filter. This means that the second layout filter here does not need to exist. And our positioning and painting is probably correct, because we need to position and paint. We need to paint fixed widgets, and then in the end we paint the floating widgets because they exist on a different layer. But I think this is fine. We have now garnered more warnings, but I think that's okay. Let's have a look at what this thing looks like then, right? Okay, that happens to be right. If we set the left to 0 and the top to 0, it should stay put. If we change the -1, there we go. Yeah, that is how it should work if it was a relative position, right? How did I end up here? Demo, please. Now, if this was an absolute position, so placement is absolute, then it should end up here now. And it does. That seemed a little bit too easy. What happens if we put an alignment in here? And we say that you are relative with no particular top, left, or whatever. Can we, and I think we might not be able to, but can we set a background on an alignment? We can. Now this is slightly different, right? The alignment has received the constraint of the viewport. So this is correct. If we move these around, there you go, right? Let's make the border a little bit larger so this becomes a little bit more visible. Now, if I say to our alignment to align yourself in the middle. Now, this position is wrong, actually. Why is it so wrong? Is it because of this padding? Wait, is it wrong? Yeah, I mean, that is obviously wrong. That shouldn't move it. So something is wrong there. But is this wrong? Okay, if we think about it, right? We have 1, 2. Okay, let's make you blue so I can see my select. So I can see the text, right? Okay, that is 3 cells there and 4 cells there. That is correct. That is 5 cells there, and this has to be 4 cells. That is also correct. So if we make this thing, there we go. Now it is centered. That's an issue with division more than anything, right? But why is this thing moving it to the right? That is, what? Why is it moving it to the right? All right. Can we set a background to a position, right? We cannot. I don't think a position can have a background. It can have a text. No. So a position doesn't have styling. And that makes sense because that would just make a mess. But an alignment does. Wow, we knew the size of the alignment, didn't we? Because it's inside the position. Yeah, that also makes sense. That makes perfect sense. That's exactly how it should work. This is a little bit confusing. Why is it to the right? But it's in the middle now. Oh. Right. That actually makes some kind of sense, right? No, I thought that would work. So it has positioned this in the center, but then the text is not. So it hasn't centered the text. Like you would here. Although now it's centered. There and there. Right? Okay, good grief. Let's not unpack this mess. It has positioned this thing in the center. It has done so. But it's positioned the top left corner of it in the center. Maybe this is more visible. So the border corner is in the top left. Nothing else is centered. And that makes sense. Okay, let's do this. Before we continue, let's clone the current version of Anathema in here. And let's go into our demo code, which looks like this. Let's leave this running, okay? And let's change the version to just be that. So now we're using the old version. Will it look the same? No, it's not working in the old version. That's fascinating. It's not doing it. So that makes me think this was even more wrong. Okay, that is fine. I think I can delete my brain. Yeah, let's just leave it there, right? So the old version, which I thought was broken, is really broken. But maybe the center alignment isn't working as it should do. Whoops. Let's put the correct version back here. And let's do this then. Let's get rid of the position from here. Okay, so now it's gonna do that. Why is it not? It's because it gets the constraint from the parent, right? Not the child. So if we were to do that, then this would start working, right? So the constraint that we get here, the constraint we get for this is effectively the entirety of this. We could do this with a container maybe. So if we place or rather we can do it with a border and we say the min width or the width is 100. Nope, that one just went nuts. Okay, container. Background yellow. Nope, the width overrides that one as well. What if it was a min width? Yeah, no, it has the same rules. I don't know why I thought that would be different. Okay, so a width will just override the constraint, which kind of makes sense because you might want to force a width outside. So we are not able to see. What about an overflow? Without a width. No, that one gets the same constraint as the parent. No, it gets the constraint from there. So if we get rid of view, there we go, right? I think we're good. This is the lightest shirt I have. I have no idea how old this thing is. But it's the only thing that doesn't cook me right now. I think this is the correct behavior because we have placed this in the center. The top left of this is positioned in the center. So it is correct. Now, if we were to go back to this conversation of the modal window, the way you would present a modal window would not be that way, right? Let's say that we have visible is false, and we're gonna have a VStack here with some text in it, right? Hello world, right? Are you happy? All right. Let's all enjoy some existential crisis. Now, obviously, there's something not quite right here. So I see a different issue that needs to be dealt with. No, I don't. Where does the blue come in? Why does the align? Oh, right, because it's right underneath the border. The thing is, it shouldn't be there in the first place. That one, right, that one shouldn't be visible. And we're gonna go back and do what we have done in the past with the border, layout, each, and then here we have to break. We do break. Then why do we try to lay out a secondary child? That's weird. I don't know what license that would be, Gandalf. I don't think that exists. But also, don't you want it to be trained on your code so it can help you with your code? All right. That's kind of like helping you organize your thoughts around your code. I could see that being useful. Having an Evin plugin is probably pretty cool, but I don't know how I would use an AI for programming what I'm doing, right? I think it might not be helpful. I'd rather use an AI to give me answers to questions, either like a search engine or to give me answers to questions that are algorithmic and verifiable, right? Oh, I see. So you mean like that? Yeah, no, I'm the wrong person to answer that. Right. This is weird. This shouldn't continue. This should never see the secondary child of the border. So why does it? Why is the alignment even there if we're breaking here? I imagine that it's a bug. It is a bug. Okay. Wow, that's kind of interesting. Maybe we could just throw a double question mark in there and be done with it. Well, we still have to do this. No? What if we match on you then? Okay. Can you not be there now? You are still there, you blasted thing, alright? So we clearly break out of here. The offset does not exist anymore. The offset was a thought that never came to be. Hello, Bonin. How you doing? I did last stream. You weren't here, or was it the one before that? And I specifically asked everyone not to redeem Game Doll and wait for you, and they did for probably over an hour, and you never turn up. I'm not saying this because I want you to feel bad. I'm saying this because I want you to feel good that we put it on hold and waited a whole hour. You should feel special. Okay, so this is the menu layout. That is not the one that we care for. Rather, why is this generating the other widget? Don't run anything local, Gandalf. That's a waste of time. I have tried with my setup, which isn't terrible, but for running Olam or whatever, it has been pretty mid. Right. Okay, so let's see where we are with the break-in test then, right? Okay, we definitely have some outputs that are wrong, but I'm okay with that. Because they are wrong in a way that shows that they are there, which means it can be fixed. But more importantly, why not? Yeah, the Days of Wordle was kind of fun, but it got a bit distracting in the end. Why does the alignment exist? The border has one widget. Nothing else is created. This should just be one widget. So we're calling inner edge here. Ah, right. And if it's break, then we return. Okay, control flow break. Is that perchance what we should do? No, it is not. Please don't draw the alignment. Thank you. Okay. Oof. Hello, Marvin. How you doing? Oh, man. I'm interested to hear that works out, Gandalf. So do keep me appraised. I wouldn't mind having some kind of useful feedback loop when I'm not streaming, or soon enough. If I want to ask questions, I can ask them. I can ask them in chat or whatever, right? But when I'm on my own, brain dumping is useful, and that will prevent me from creating these brain threads on the Discord where I'm just rambling. I could ramble into an AI. So the first thing I would do is say, don't reply to anything I say to the AI, and it would leave me alone, right? They claim we do not use, share, store, or train on your code data beyond what is necessary to provide our service. Yeah, that is the most vague bullshit ever, right? That basically is a get out of jail for free card, right? You can't imagine that is not gonna be like, if you see your code somewhere else, you'd be like, hang on, I wrote that code. But yeah, we needed to use that to offer our services. What are your services? To offer your code to other people. Did you not read the small print? Yeah, that's it, Gandalf. That's it. Okay, so I think this fixes it. Now we need to see what the so we're going to move the alignment in here now. So this should work. It does. So this one is not a floating widget, but it will use the remainder of the constraint. So if we were to put this underneath, it will never be there. Wow. Okay. That's a bug if I ever saw one. Well, luckily, this is the next thing to work on, but let's go and write a test case for that now. Actually, let's do this so we can come back to that one if we need to run something. Let's first see if these things are now woefully broken. They are, so we're good. Let's go into tests and let's make a test for this thing. And we're going to call this thing align or VStack alignment. So let's go to nested collections. Actually, we don't need nested collection for this. We can do state change, which is a simple test, VStack alignment. There we go. We don't need a key press for this thing. Our template should simply read VStack text hello, followed by, whoops, an alignment. And then we have align text. Now this thing should break. We don't even need a custom anything. We just pass in the template in here and this should break. We do not care about that. We don't need a component for this. We don't need to do anything here. And it broke. No, it can't compile it. What's the compiler error? No semicolon. There we go. Okay, so we got a failing test for this now, which is great. Oh, sorry, Pepper. I haven't started the bot yet, so we can't see any of that. Let me see if we can start the bot then, right? Binky Bunny bot. Simple bun. Oh, right. And the cleanup session. Okay. No, we can't start that one. All right. We'll have to finish this first. So at least we have a test for this. Now we can go back to the failing ones. Okay. So let's go and look at the position bottom, right? Position. This guy here. This is what's failing. If we say 0, 0 in the bottom right, given this input, that's what we should get, okay? So let's make this happen, all right? Let's write this into a demo. We already have a test for this guy now, so we can ignore all of this code. And we can just say border width 10, height 7, text hello, run this. It should just say hello and then put a position that is bottom 0. Wow, that is not the bottom that we expect. Okay, let's go and look at the position. So first of all, we talked about the size, right? And maybe this is the issue where we don't store, well, no, we store this constraint. So that is correct. Let's look at what positioning here actually means. We're getting a position here. If it's absolute, then we are changing the context position to 0. That makes sense. Since this one should only run 1. Oh yeah, I hadn't finished that yet, right? Hello, Tempe. How you doing, buddy? So let's look at a bottom position. So we're looking at the context inner size height for this thing. So let's put a breakpoint here then to find out what it is that we're actually getting. What is this? All right, never mind then. Yeah. Okay, let's start with this thing. It is not absolute. So let's look at the context position before we do anything. Okay, it's 1, 1, which is correct. But given the border, that's what we're working on, right? Now, if things were great, we could have printed context.inner size here, but oh no, we can't. It has no inner size. Well, that's just stupid. Why don't you have an inner size? All right, let's go up then and find out where is the inner size created. We have inner bounds. That's the self cache size. Oh. I'm coming over to your part of the world, Bulov King. Your part of the world, let's say. Let's see if I don't live in Europe. Are you in the south? Do you want to hang out and work out one day? So I can see if you can really do shoulder press with as heavy as you pretend to. How you doing, Skylar? You're in the middle. No, I'm just gonna be oh, I haven't progressed anywhere with that, Marvin. I'm still on some pretty measly weights with that. You're in the middle. That's too far for me, I'm afraid. Happy Ultimate. Ultimate is never happy. Okay, let's see. Where do we get the size? It comes from the cache. So then something has gone wrong with the layout here and the caching. Okay, let's have a look at this then. So when we update our cache size, let's just run this from the start again. And this is not the, this is the border, right? There isn't any information. Let's do this. This is the border. So the size that we get from the border, we can't see that. We can do this. That is the size we get from the border. That is okay. Now we're gonna lay this out. No, we're not. What happened? This is the layout. Why are we ending up here? Oh, all right. We can. Don't eat the cold path, Skylar. That's gross. Put it back. Let's run this. Okay. So we're now in the layout step of things. We're setting up our edges for this. So our size is now 0 by 0. That's kind of shit. Well, that means the maximum size doesn't work, does it? What? Oh shit, idiot warning. Okay, I found the bug. Whoopsie. What an idiot. Alright then. Okay. There we go. Okay. Almost everything is working now. Alright, let's have a look. What am I missing here, says Perkins? Apparently I can't. Let's see, what do you got? You got a node and you got a box option. Oh god damn it, don't do this. Most likely this is not what you want, okay. Oh, okay. Serialize. Cursor is tree root, output is vec new. While cursor is not none, tree root is possibly none, okay. Push some cursor clone unwrap data. All right, so you are pushing the data into the output. Now this makes no sense. Cursor as ref, unwrap and then left. Okay, you can do this. You can do this up. Okay, it doesn't matter, right? Use while let some cursor instead, right? That would make more sense. While let some cursor equals cursor, because you're cloning it anyway, right? Actually, no, that doesn't make any sense either. Sorry, this is fine. The cursor is now the left one. You're not pushing the left data though, are you? Is a shader in the terminal? That's cool. Left first always. Yeah, sorry, I don't see that. I see that. Oh, because of this. Okay, that's the left one. Sorry. And then you push none to the output. So if left is not none, then it's left. Okay, I don't know why we're pushing so many none here. All right, I have to run this. I have to like step through this. Man, I have no idea what this is. Let's do another one. Okay. Apparently. All right, so what's the tree supposed to be, right? You have 3, 4, 5, 42. 3, 4, 5, 42. Okay, so what is it that is confusing about this? Let's see. You seem to be doing something. Oh, yeah. So the question was, what am I missing here? What is it that you're expecting here? So you have to help me out with that one, right? So that's the root followed by the left one, and the right one is none for that, right? So that's the root. Oh, no. Okay. So each node has data and leaves or branches. Sorry, not the other way around. Okay. So root has data, and then this one has data, and then right has data of 5. And then the left of that one has 42, and nothing else in here, and nothing on the right one, and nothing on the right one there, right? Yeah, it ends on none because you have 2 none here, right? So the way, if you were to maybe, if you look at how the tree is constructed, this seems fine to me, right? You start off with the root being 3. That's this guy here. Then the first left node of the root is 4. And if we go to the right node of that one, that's 5. No, this is the this is what's so confusing. The data is 4, but the left node is none and the right node is 5. And here, the left node is 42 and the right one is none. And then finally you have a none down here. So that is right. So I don't actually see the... Now you say serialized, but this is not really serialization. Well, maybe it is a serialization, but what are you serializing it to, right? There's meaning to the order here, but you can't deserialize this data, right? Because you have 1, 2, 3, 4, 5 nuns in there, and you have 1, 2, 3 here, right? You have more data here than you have in the serialized output. And if you don't have the other nuns, there's no way for you to actually, you couldn't reconstruct the tree with that anyway. So the serialization is kind of meaningless because you have no idea looking, whoops. Where did I end up? Okay, hang on. You have no idea looking at this output. You know that's the root, but that's all you know, right? You don't know what this none is, and you don't know what these 2 nuns is. Like maybe you can discern that what this thing is, but there is no way of knowing what's left and right of these things, yeah? The order, well, the order is not really relevant either, right? And I do wonder, and when I say it's not relevant, what I'm actually saying is that the order doesn't make it less wrong, but I could be wrong here. So let's see if we could make an alternative of this, right? So we're supposed to have 3, 4. If we put some, no, that's none. If we put a node here, if we swap these 2 around, now there is a difference here. You can see a difference there, but something tells me that you can change the order of the tree and it will be wrong. Like the way things are output here is not gonna be what you could not deserialize this data from that, right? Yeah, I think if you're gonna serialize this, then question is about the order. So you're basically missing information, right? If you were to serialize this, maybe do something like store the parent as part of this. But more importantly, why store the values like this in the first place and not store them as a flat collection? That would make it so much easier, right? Hello, Danaka. I'm gonna finish what I'm doing because I'm not the best person to talk about these things. All right, But we can come back to that maybe. I want to fix this test. But when you talk about serializing something though, you need to retain enough information that you can take the format and reconstruct the origin. Otherwise, you could just write sandwich in there, right? Because the data is meaningless, right? If we're generally talking about serialization, which should be countered by deserialization at some point, right? It's all good, Perkins. Sorry, I'm not more helpful with that. My brain is a little bit too invested in this thing now. But I shall have a look in a bit, maybe. We can talk about that. If we can get into more details about what you want to do and what the requirements are, then maybe I could have a more useful input, right? Okay, so what actually has broken now is the vertical stack overflow, which probably comes as a result of what we changed. If we go back to not the runtime, but the widgets tree module. Right, there you go. So where we have this, right? This is probably what has broken things. So let's put things back to what they were first and see if this will change. No, so the vertical stack is still broken as a result of that. But there's another one where we do this, and it is here. And let's see if this has any impact on that particular test. It does. So it's clearly an issue there, right? Where it doesn't work. So, but I do think the logic around it is correct. So it's more likely that the test is vocal than not. So we're going to start by adding this in and see if that still passes the test. It does. And then we're going to go back and add this thing. Oh, before we add this in, let's do a brief analysis of what this thing actually does. All right. So we're going to break the loop entirely here. If we process and this returns a break. As in we don't continue anything. We just stop. This would make the test pass again, but I do think that this is incorrect. No, it didn't. Will this make the test pass again? Yeah. And that doesn't seem right with me. That breaking should continue. That just seems, weird. So this should break out of the outer loop first. Now, I do want to add the first function in here as well at some point. So let's add that in there, but we'll come back to that one. Let's make this thing work. The first thing we're going to do is make sure that the test is actually correct, okay? So we'll find, is it the VStack overflow that is failing? Index out of bounds. Okay, let's go and recreate that in here. Actually don't need that. Anyway. Yeah, that makes sense, Perkins, if left is none. Okay, let's go to our index ammo and let's start sort of... So this is now correct. So if we do right here, it will position this thing in the right corner, right? And the nice thing about this is that it will position it... The right side of the element is in the right corner, not the rest, not the left side of the element. like so, which would be, you know, shit. But anyway, that is not what we're doing now. We're doing a vertical stack here. And we're just going to have some text. Let's put a border around this so we can see this. I do believe that we have a constraint on this border 6 by 2. Now, that constraint is not the constraint of the border that we just do that, but we have to add the size of the border to this, which is why we add the plus there, right? Okay. How many? Hello. First of all, let's get out of there. Let's get into. Is this default widget? No, this is what we're gonna look at later. Okay, so we've got A, B, C, D in there, and we're expecting to see A, B. So let's just go with the same thing here. A is there, B is there, and this should now break perchance. Yes, it does. Okay. It breaks because we have created this thing, but we never did layouts on it. And I think this is a result of the widgets either exist and has no layout. So it shouldn't go through the paint stage at all, right? So let's make that work. Now we could codify this, but I think it would be encouraging incorrect behavior by having the checks, right? And I'm not sure. I'm not sure. We'll see. Let's see. Where do we go through the layout here? Let's go to text. Actually, we have to go from here. So I don't think this will happen 3 times, but I do think that the paint will happen, or the position will happen. Actually, the position does nothing, but I do believe the paint will happen 3 times. Okay. So if we count, this is the first time laying out. Now we've done 2. Now we're painting the first one. Now we're painting the second one. And here we're about to paint the 3rd one. So the widget exists, but it has no... It has not been laid out. So it's in an invalid state. All right. If we were to look at the context for this thing, it would have no size. We could, again, we could codify this by saying if the context dot size, if you can spell size, is 0, then return. And this would now... No size on the context? What do you have for me then? I'm sure I saw size in here. Local size. All right. And now this would quote unquote work because we don't do anything in there, right? But it means that we are creating a widget but never running the layout function for that widget. So it's not laid out. That means that the widget has no cache, right? It's a poor widget. So the first one is fine. The second one is fine. The third one is not. If we go up here and up again and print self.cache, this cache should be invalid. And it is. So we shouldn't necessarily paint on invalid cache widgets, nor should we position, right? So a widget has to go through the process of layout for that to work. Now the question is, if we do that here, if self.cache is valid, is that a question? Is that a function for valid? There isn't. We can look if it has a size though. So in this case, we're saying that you don't have a valid cache. We cannot and will not do anything right about this step, right? So you must have gone through the other steps and now everything should work. And it does. We have some warnings we're gonna deal with though. Right, so needs layout seems to be, well, the whole floating part seems to be irrelevant now, right? Okay, sorry. Blah. Where do we go from here? Let's get that test that I added into a compiling state, right? Okay, it is a compiling state now. So it wasn't really about the alignment of the vertical stack, even though it was, but that was another issue. So now this test is actually not required anymore. So we're going to remove the VStack alignment test. Even though having more tests is great, it's not really going to do anything for us because we're testing a unique edge case that was not unique or an edge case, right? So let's see what we got in terms of warnings then, right? Again, we are very close to merging this into main now. Okay, so we don't need that. So examples and tests needs update. Is this all down to the examples and tests? Yeah. Okay, let's go and up. Ooh, Nelly, no. Okay, let's go into widgets. So it's more important to fix these things than not, right? No, stop running the test. Cargo check, please. Check, please. So the position is not required here. And we don't need the ident for the element either. That was clearly something that I was debugging yesterday. I had a very productive evening yesterday and I was so tired afterwards, but I got a lot done. All right, so that one is now free of warnings. Let's see, what else do we have? Let's cargo check everything again. In the backend and default widgets. Okay, let's go to default widgets. We were just there. Layout many 83 is okay. So the offset is no longer required. We're just going to get rid of the offset. Wait a second. Yes, for that maybe, but not for. Yes, okay, that's good. And was there something else here that had an issue? Overflow 18. I don't think we're doing anything with this offset. We are not. Okay, cool. Then it's the back end. This I do love. I don't love fixing warnings. There are more fun things you can do than that. I think we can simply get rid of layout from here, which also means that this thing can go, which means that the run function do not need that. This should subsequently give us a performance improvement, what has been done now, because we're not dealing with widgets that cannot exist, right? But it's too early to care about that, right? I have had my fair share of the password game, Maniac. I don't want to play that on stream again. Not because I'm afraid to look like an idiot. I do that anyway, but it's fun until it isn't. I have played the password game. Okay, so we have quite a lot of warnings here that needs to go as well. And this is coming from the tests. So let's go into the tests and let's run cargo test here. And let's deal with these warnings, right? State change. What was your gripe? No, that's the example. 10. You don't need to be mutable, nor does that need to be mutable. As a matter of fact, we didn't even use any of this or that, so we can get rid of that. Oh, the examples needs fixing, don't they? Okay, let's go to nested collections 26. We don't need mutable children because we don't do anything with them. Nor do we need a mutable context. As a matter of fact, we don't do anything here, so these things can simply cease to be of any relevance, as they are in fact not. Is that all the test code? So it's just examples now? No. State change. 4. All right, let's go and fix the examples. Even the basic example has an issue. Okay, so let's do, whoops, cargo check example basic. Okay, unused result. That one is simple enough. Let's just unwrap this. And that's it, right? This should now be fine. What about the buttons? Okay, we got a little bit of growthiness there. Yeah, I mean, it's a really cool idea. For those of you who haven't played the password game, do check it out. It's free to play in the browser. And, I mean, it's a brain teaser, right? But I do think it's funny that it exists, especially if you ever dealt with passwords in your life. I mean, if you haven't, then you're either 5 or very fruity in terms of what you do with your privacy. But it's a verb. Check it out. Fruity. What's it talking about? Yes, anyway, so we're going to fix the buttons now, right? Let's go and fix the buttons. And let's see, we need to fix 60, 65, and that's it. Okay, so let's start with 65 because that one was easy, okay? As in, we don't do anything here, right? And then it was 60, was it? And that's probably because we don't use the state there. All right, then it's just animate that is left. And that is the elements in 30, 45, and 46 don't need to be there. So we start with 30, and then 45. Brimful of Asher on the 40. All right, and then let's do a check, and that's it. So we should have no warnings now. All right, what does the test look like? Ugh, okay, not as optimistic. We have some here. Okay, message passing has state and attrs that we don't need. I don't think we need that state. And we do need those attributes. Wow, we just run it again. Okay, nested collection suddenly has issues. Where were these warnings before? Do cargo clip. Don't tell me what to do. Right? You're not my real mom. Examples, message passing, 26. Okay, we don't want attributes. Clippy comes later. You get everything working, and then you deal with Clippy. Okay, so 28, we do need attributes there. Okay, that was wrong. So what was the issue then? Do we have attributes anywhere else? Look at all these beautiful passing tests though, right? There are many of them. Many tests. Hundreds of tests even. Goodness Cretaceous. All right, we're just going to leave this open. All right, I'm a little bit confused here. Well, I'm very confused here. So this one says the attribute is not used, but they clearly are. On line 26. Oh. Oh no. But the query is fixed now. I think Skylar fixed it. Again, not my real mom. Message passing 28. Okay, but that should fix a lot of these warnings. If this intentional blah 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 underscore key, that's nested collections 26. Let's go there. We need state. We don't need key. All right, what's the other issue? Anathema strings, that doesn't even exist anymore. Where am I? It is there. I thought I got rid of this project. What? Okay, I thought I got rid of this project. I might resuscitate that because we're going to look at strings again at some point. Because who doesn't love string layout? Okay, text layout is one of the most fun things you can do with your friends and the family that you don't like. Okay, state strings lib and then what line number? 206. 206. Okay, that's it. So we're just going to unwrap that, obviously. What else is wrong here? Variant S is not covered, so it's going to be in the tree view 246. That's somewhere else. That's the storage. What line number? 249. Okay, so we don't use that value for anything. Let's just change that to not be a value, but to be a use size instead. Value. Oh, you're completely off there, aren't you? So we're just going to change that. And that. And subsequently that. And that. And that. And that. Okay, anything else? Yes, 367 is, that should be a use size. Anything else? Apparently not. Okay. Eep. There's no unrav. Okay, well, that makes sense. Unrav. There we go. No, damn it. Stop running the test. Come on. T-marks. Don't do this to me. There we go. Test base as a prelude we don't need. That makes sense. I don't think we need test base at all. So let's go into tests and remove the base. No, we don't need it. Wow, look at that. No warnings, none whatsoever. Then we're going to add this in. First, we're going to run a cargo nightly format. Now, we're going to run Clippy and see if we care about this. Yes, yes, and yes, and yes. All these Clippy issues are valid so far. Definitely. Okay, we'll see to that one in a bit. Yeah, I know. That one, I don't know if that's relevant. But a lot of these ones are. So let's go and fix tree transaction. Which line? 62. There we go, because these values are already a mutable reference. A lot of these things that we see now are just residual from when things might not have been that. Okay, 175. No, that's not the right place. That was in view. This is in tree. That was in transaction. This is in tree view. Okay. All right, let's go all the way up here. Okay, so we fixed that one. Then it's going to be tree view 149. 149. Okay. There we go. That's one. Wait, did I remove the wrong thing? No. That's fine. Yeah. Okay, 175. It's not the most fun thing you can do, but it kind of has to be done. Quality of code doesn't necessarily go up. It tends to go down. 187 over time. This code was written before I was born, yet it was also written by me. You have to work that out. 217. That is probably that guy. Self layout as well. That is also, that's why these are copied from the tree and moved into the tree view. That's why they are like this. Okay, let's see what else do we have. All right, we're gonna go on top of our water and decide what to do with these things. It's now 2 hours. All green and passing. Yeah, we're about to merge with Maine. Right, I'm just gonna top up my water. All right. We got our drinky poos. And we are ready to tackle the last issue here. Now, the issue here seems legit, but we got to figure it out, right? Try and build something using test-driven development in Rust. Ooh, How big does it have to be, though? Right, the project, if you want context. So the everything has to be written as a test first, right? So everything is tests. For that to make sense, a whole stream. I mean, I can spend 4 hours on writing 3 lines of code, so that doesn't make a lot of sense. But but here's the thing: do we do this also with entirely trait based as well? So we can write the traits first, or do we let the whole test thing just not compile because of all the missing types or that? So what I'm thinking is, if we do this with traits, then we can quite quickly write this up, but the test will never compile if we don't have the types. Okay, so we can skip all the traits in that case. Sorry, Wiry. All right, let's see if we can get. But we got a few things to do first. We're gonna appease Clippy or figure out what we think about this. Then we're gonna get the bot back and running again. All right. All right. And I have to update the documentation. There's a few things. I got a PR waiting to be merged and a few other things in there, right? Sorry, Wiry. All right, so operator present might not be obvious. All right, let's go to the generational and look at line 93. So this thing, I mean, what is it that is not obvious about that? So this thing says that we should wrap the second part in brackets as well, like this. Okay. What's the partial equal implementation for this? See, I don't think this is wrong. This is all operating on this thing, right? Oh, it does have the generation, though. Maybe. Maybe this could be wrong. Because you could accidentally compare 2 keys with different generations and they would be wrong. But surely I must have thought about that when I wrote this. So I think the quality is probably used somewhere else. First of all, do we need hash for this key in the first place? I don't think we do, right? Apparently we do need. And I think the quality. Oh wow, there's a lot of gripes here. Return the expression directly. No, go shut up, Clippy. All right. Remove control for that. That I'm on board with. All right, but we got rid of the hash now. No, why? That returns an option. What the hell? Non-canonical implementation of partial odd on an odd type. Alright, this one feels a little bit grubby and weird. When odd is already implemented. Okay. Well, we could get rid of odd and partial odd here. And see where they are used, right? That's why. Growing object-oriented software guided by tests. If you ever read it. No, I have not read that. Is it a good read? I haven't read an awful lot about object-oriented programming, right? Why do we have partial equal on the entry? This is why, but this should just be index and index, right? This is a bit sketchy. I don't know if that would put, I think that would just make me bored and subsequently make you bored if we did that. All right, we have to read through this because this one is a little bit iffy. If we have a vacant entry here, then we look if the next ID is free. How is this used? Find the values that points to index and replace that with, is this part of like insert? Oh, it's insert at. Oh my god. Okay. Is this used anywhere? Because this is a hairy function. Yeah, it is. No, it isn't. Can we get rid of this whole thing? That would be pretty sassy if we could. Probably not the best way of describing this, but... Okay, no one cares about you. Go back. All right. That one just seemed to be depending on the index. Okay, let's just roll this back to the point where we had that. All right. And then we take insert at out. Whoops, that was more than that. I can imagine some tests will fail now, but that's just going to be tests for that, right? So yeah, this one isn't even done. That test is stupid. Oh, goodness me. Please tell me we can remove that. We can. Oh, you shall burn, you filthy function. You were large and unwieldy. All right. Oh, beautiful. This is great. Being able to delete large chunks of code makes me so happy. Whee! All right, Clippy, go back to bitchin'. All right, then there was the hash function, and we needed that for some reason. If you think that's large, JD, I can impress you rather well then. How you doing? this is where we store type information now. The auxiliary storage, which is pretty good. Hello, Piples. How you doing? Good guy, peoples. Okay. So when we're comparing two keys, we're doing this just by the index. And I think that might be a little bit wrong. So we might have to do partial equal and partial odd here. Well, luckily, we have the tests to see if any of that broke anything. Yeah, it did. I did have a good weekend, thank you. Very productive. I didn't sit down here doing any program. I did programming, but didn't sit down here doing programming all weekend. It was really nice. I sat in the sofa with the missus, watching TV with my laptop in my lap. Hence the name, right? Writing code and fiddling with these things. It's been pretty good. How was yours? Oh, that was insane, Maniac. Again, thank you for an insane amount of gift subs. For those who didn't watch that stream, you missed a historical moment. I was working on the UI that's here, but every time someone subscribed, the UI would break. So while I was trying to fix it, people kept kind of subscribing and breaking it. It was pretty epic, and it was a very nice stream. And I felt really good afterwards. It was one of those moments where you kind of like, if you're a streamer and you stream, sometimes you walk away from the stream and you kind of feel a bit weird about the whole thing. Sorry, I just had to check something on my phone. You feel a bit like broken in the brain after a stream, right? Almost like a hangover. And sometimes you have streams where you just like you're walking on clouds afterwards, you feel amazing. And that was one of those streams where everything was just absolutely fantastic. It was fun. I had fun. People seemed to have fun. And it was just all around enjoyable, right? Why is my phone not working? All right, there we go. Yeah, so we're going to get rid of this, and close that down. There we go. I should have a highlight video of that, Maniac. Okay, let me scroll through chat, sorry. Not terrible. I would take that as a good thing, JD. When you make the compiler complain, are you doing it intentionally, even though you know how to write perfect code? Yes, Bonin. It's all for clout. But don't tell the other viewers, because then they might have high expectations of me and might get a bit much, you know? What did I get for Father's Day? Well, I don't get anything for Father's Day. I do get something. I get like letters and things from my kid. But those make no sense to share with stream. Dad, thank you for being amazing. Can I have money? Thanks, bye. Signed, the child. Historical hyperventilation. Oh yeah, I was lightheaded from that stream. Maybe that's why I felt so good afterwards, right? You could pinpoint the time when the brain was fried. Yeah. Oh, a fly. All right. Mm. I can tell you guys how many there were. 1 second. Let me pop open the stream summary. 256 subs last stream. That is unheard of in my stream, almost. How long was the stream? The brain usually starts steaming around the 5-hour mark. I think maybe I don't exactly remember how long it was. It was probably around 5 hours, I think. I also didn't have any food. I had a really crappy breakfast, and that's all. But not today. I had a protein shake and a whole apple, so we're gonna be good, even though it's lunch. That's about right, Marvin. But that doesn't say much in general. But yeah, that number of subs is roughly what I have in a month, right? That was insane. Yeah, no. So I had. So it's more. It's not. This like in one stream. Temporis as opposed to over. I mean, like we both know you kind of got the leaderboard there. Come here, fly. You got the leaderboard there, but it's more like when someone has dumped a large quantity. I think Crimson Mana has when we've been like building keyboards. The reason I got that hot air station was because Crimson Mana jumped up to 100 subs in there as well. All right. Oh yeah, Hardliner is also gifted like an insane amount of subs, right? The other day when Hardliner showed up and dumped a bunch of subs. Yeah, no, it was I think this stream there were probably about 170 subs within less than an hour, right? That's how that unfolded, right? Can't drink through the lid. It was insane. It was a moment. Okay, let me see if I can fix this. All right, but we have a test that is failing now. I thought. I was sure. Oh, we got the alerts going, and I see the audio now. Thank you so much, Temporis. Thank you. Oh, little buddy's going to the vet soon, just to have his eyes checked. Nothing serious. Thank you so much, Temporis. We got the hat out. We got the hat in the background. The hat you can see there was out. It's been a while. Brutal. Okay, so store value. Where is that? It's in state. Yeah, so I've broken something now. And that's not good. Thank goodness we have just one thing here. Oh, can you fly somewhere else, please? It's so frustrating. Okay, the left comparison to the right and 107. So why are these failing? Yeah, because they contain auxiliary data. So we can't do an equality check of the key. That is why we need to be able to compare those. I don't actually know how they differ. So let's just print out the keys here. So this is going to look a little bit weird because the keys are actually packed with other information. 0. So if we run this, wow, beans. Okay, let's just do this. Oh, no, we get the debug representation of that. I'm not sure I saw your pun, Bonin. Go for it, Maniac. Yeah, rain is nice. Rain can be... Oh. Come on. It's not like I'm going to be able to catch it anyway, right? I don't have the reaction skill of an FPS gamer. So what do we do then? We have to have partial equality for this, but if we do this, then Clippy will gripe, but the test should be good because we're comparing two indices. But it's not just the index though, right? We have to do self.gen. And maybe even the auxiliary data too, for it to be all... Ugh, rubbish. We can't compare generations. See, the top left bits aren't relevant when we're comparing the keys, are they? That returns an owned key, which is a slab key. Okay, what we could do is we can print the index of this. Let's do this. Key owned index and that index. So they should be the same now, right? Oh, mittens. Right, they're both 0. What about the generation? Oh. Damn you, Rust 2024 and your keyword sneak. All right. That's the thing. They have different auxiliary data. So there's different type information stored there, right? Thank you again, Temporis. Is there really a difference here? Why is there different type information here anyway? Yeah, because we make that a thing. Yeah, they shouldn't. This test shouldn't pass. I don't think we have a 0 type. No. You're not allowed to have a 0 type. So this 0 key is invalid. Wow, what does this mean? That we can't really use the 0? We can set the auxiliary value for that. I think that might work. Maybe if I could spell. Ooh, that is not right. Oh yeah, it is though, right? We should change this to comp. Okay, so the test was wrong. Okay. There we go. So compare to 0. Like that. 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 Like Yeah, we didn't have to say that because it's generic. Okay, wow, that was interesting. I didn't promise it right now. I said we're about to merge into main, though. What do I think about reflection in Rust? Not sure. Hello, Privan. How you doing? Are you a rookie? Yes. You can't say the F word. Automod. Yeah, but what is it that you're forcing though, right? Isn't that going to be main? Okay, so cargo test all. I wish it showed us how many tests in total we had, because this is quite a few tests. 13, 50, 112, 3, 51, 26, 67. It's gonna be a few. What we could do? Maybe we could do like oops, I didn't want to do that, right? So let's do this. Let's just grab running. Oh, where did they all go? Right, there we go. There's 1, 2, 11, 78, 82, 108, 159, 162, 274, 334, 350, no, 47, 347, 349, 353, 364, 366. So about 366 tests. Could that be right? Can we do... Oops. $20. No, I don't think that was quite right. Yeah. Anyway. How you doing, Privis? I got a new date for you. She's not a robot this time. No, but I'll be in your neck of the woods on... is it the 2nd or 3rd? I'm going to figure this out. 2nd or 3rd, I think, in July. And I'm going to be there for one night before I head out again to go somewhere else and meet other people. So if we don't do any podcasting, which it might be a bit hectic to do that, but if you just want to meet up at some like local cafe or something, then I'll be up for that. You can tell me what's good. I'm going to take my kid shopping because she needs a new t-shirt. Man, the fly is sitting on the blinds. Come on, fly. Don't just taunting me. You can bring it up, Bonin, but I'm sort of like doing something, so I'm kind of invested in trying to release this. So I did see a library and some blog posts about Rust Reflection recently, so I kind of just chalked it down to being that. So I don't know if we can this year, Marvin. We were gonna head over to Hamburg, amongst other places as well. But this pipe thing kind of just completely us over, right? Whatever longer holiday we had planned kind of got scrapped with that. But that's just live things, right? Do I even know your neck of the woods? Well, was I far off? Oh man, we could could have had some Stremolax though, right? That would have been a thing. Go on a world tour to see views. I mean, that would be fun, Caleb, but unfortunately there's too many Daves around you, so I can't go there. Yeah, I'll do that, Privan. I'll let you know. Okay, so where are we at with Clippy now? All right, there's quite a lot of griping here, but I think most of this is fine. We can probably auto fix a lot of these things. Let's do a commit before we do that. So let's do a git add -p. Let's patch this and see what's been added, right? Riding kangaroo. I don't think you're supposed to ride them, okay? How you doing, Roberto? Yeah, I think the frustration and anger from people mostly stems from where they are in life, right? If I am in a good place, then I don't care that much what's going on and what people want to talk about, even though it has no interest to me whatsoever, or the fact that people are violently trying to backseat until I die. Now, these things don't faze me as much, but if I'm living inside a toilet because my house is one, because shit happens, literally, then I'm less like, then I would be more annoyed with things and that will bleed through, right? So it definitely has a big difference depending on like what's what, right? Okay, so this is a lot of fixes, style fixes and stuff. So what is the main part of this work? Okay, we did decide that that was correct. So we're going to nope on that one. We don't need that note. You might have to best kangaroos in hand-to-hand combat first. Aren't they insanely dangerous? And more than fighting with a fist, they will like kick you to death? Okay, so we fixed the layer thing. So, okay, this thing merges layouts into a singular step. That's one advantage we do. I took out display error because we're not there yet. That's a test. So these are all comments. We'll say no to these. We're going to fix those. So really what we're looking at here is reduce one layout step is what we've done. And then we remove this chunky code here. This was never pleasant. I'm happy that it's gone. There's a lot of clippy changes here. We don't have to note those down. Don't really care about that. That's all test changes. Not sure what to do with the strings yet. They can shred you with the claws. Yeah, I'd imagine, right? Thank you for the follow. I don't think we're going to store the position on the cache, so let's get rid of that one. And we do add that this is part of that, right? Good work, Maniac. I did that last, was it last week or last year? One of those. I think that one's a little bit more tests are always good. Made that mutable. I don't know if we need that to be mutable anymore. No, I don't think so. As a matter of fact, the whole filter thing has to go. Okay, so we're going to fix the layout filter before commit. I mean, they just look sensible. Yeah, that one should be done as well. That's new. Okay, so this one I don't even know if we're gonna have anymore, so we'll do that. That's all the... Wow, so many changes. It's a big commit. Implement widget for float. Oh yeah, it's part of the testing, right? Brain. All right, the offset can go. We don't care about that. We're gonna make first a thing, but not yet. Yeah, more cleanup. Goodness me. To not have a rum? Oh man, I can't drink rum. Okay, let's go and look at the widgets now. Yeah, do we really use the position here? No, I don't use WhatsApp. All right. Catch up with an old friend. I haven't spoken to in ages. She wants to catch up tomorrow, so let me just tell her sure. What time? Oh yeah, no WhatsApp. I forgot all about that one. Sure, we can have a catch up tomorrow. What time? Okay, so what has the cache? Yeah, we have the position here. I don't know if we need the position now. Is this right? No, I don't think so. I think we should put the position on self instead here and get rid of it from the cache. Could you fly somewhere else, please? You literally can have the whole house to yourself. Go into another room and fly. Oh, you're the worst. Okay, let's see if we broke any tests in doing this. I don't think so. Wow. Yeah, we did break some tests. Hmm. How did this crash all the tests? That clearly means that on the position... Where is the container? Yeah, obviously, right? We just say cell position, but I think that's what we need to do. Still not right. Sure. Sounds good. Let's do it. All right. That means that 12 o'clock BST, I have a call, which means I can't stream then tomorrow. So either I stream up until or after, right? ¿Por qué no los dos? ¿No los dos qué? Okay, so that wasn't right. Let's revert this. So something has to set the position on this for it to make sense. I think let's just store the position on the container like so. Okay, where does that get set? So we're going to remove the position from the cache now. Position is gone. That should just be self.position is equal to the position. Why would this fail? We just moved it. Why is it causing the test to fail? We're off by 1 on every position now. This is absolutely nanas. Okay, maybe it's a case of different types. Right? We'll revert this one more time. If we take this off the cache, which is on the container, let's go to the element, right? Let's see how this is used. This makes no sense. Why would that not work now? Okay, so we're not quite done, but why is it only paint laid out widgets? Shit. All right, so this isn't using the right position here. So something has to be setting that ruddy position for it to work. Yes. Let's do it. There's no other position in here, is there? I am very confused by this. How can these stop working? Because I moved something? I just moved from one thing to another. Well, in this case, it makes little to no sense. All I'm doing is moving it from the cache to the container. That is just insane. And what happens is we get off by 1 errors from doing this. Right? We're off by 1. So all their failing errors here is just subtract 1 from everything. How? Oh, because of the inner size? Default widget. Position, is it? Okay, this is some particularly strange bug that I can't wrap my head around. So here the position is 0 until we insert. It's either 0 or we're gonna get this position. All right. how? How does that even work? Okay, let's look at it in here. Let's run this code and see what the output is going to be, right? Okay, so that's now, let's throw some padding in here to move this one out a little. Wow. That is not right. So it just means that we don't have a position. It is 0. Right. It's supposed to be the cached position. So if we make our position into an option, that would make sense. Then why move it out of the cache in the first place, you lunatic? All right. Then this makes sense. Okay. Yeah. Because we have no cache size, so we have to update it, otherwise use the cache size. Lifetimes are great fun, Muriel. We are preparing to release this, all right? So this is not about optimization. This is about cleaning up the code. More than anything. Hello, Ivan. How you going? All right, we got a warning now, and warnings can't abide by that. All right. No position for you. All right, so let's see if we can patch the rest of this then. Right, so that one we can deal with. This is correct. Wait, was it correct? No, this wasn't correct. So we can take that out. Well, a comment's not going to affect the test, but we'll run them anyway, just because there are 300 tests there, right? Okay, so all this commented out stuff has to go as well in store generational. We're going to leave comments in there. We don't have to. So this is removed instead. We do want to add the position to the cache now. That's all the... Well, container, we can remove the comment, right? Wrong project. How's it going, Temporas? It's gone. Oh, that's what the diff says as well, right? Okay. Reduce layout to 1 step. Clean up code. Okay, now... Whew, now we should be able to do this, right? Is this UI stuff? Yeah, it's a UI library. You want to make something using Anathema? But it doesn't. Okay, what was your question? Ah, well then, there is that. Okay, so we're done with this. Now we're just gonna clippy the whole thing, right? Let's start with the back end, and let's look at the cargo clipper here. Okay, that one we can auto fix. That one we can auto fix. All of these things can be auto fixed. So far, so good. Okay, yeah, a lot of things have changed. That's perfectly fine. That's great. This thing is not related to the back end. Why is this one triggering? Okay, can we just do a cargo clippy auto fix? No. Fix. Fix. There we go. Wow, it's it might have done that to a lot of things then. All right, let's just check clipper here. It hasn't fixed any of these things. Okay, what did you do then? Okay, that one's good. That one's good. Let's just do a git add -p again, right? Yeah. Wow, first we're gonna cargo test all. No reason why it wouldn't work now, but and then we're gonna add this. Okay, that's clearly good. That's good. That's good. So at some point something was a U16 or wasn't a U16, but now it is. That's why. Okay. We're just gonna add that to the existing code. Let's go into the back end and let's run a cargo clip in here. And then walk through the stuff. Okay, it seemed to go for the widgets, so maybe we start there first then, right? If we do a cargo clippy fix here, will this do anything for us? Apparently it did fix a few things. Let's see what it actually fixed, right? Yeah, I'm on board with that. That makes sense. That makes perfect sense. So does that. Yeah, that's good. Good, 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 and good. And good, and good. Yeah, makes sense. Makes sense. Okay. Remove layout filter. Okay, yeah. So far, so good. Cargo nightly format. Make sure nothing is you know, whoops. Yeah. Some things had to be formatted there. Okay, let's amend this one. Are you doing text too? Would you mind talking a bit about your approach? Not at all, Murlo. Is there anything in particular you want to know about? I'm happy to go into details of what I remember. I've been working on this project for a while, so not everything's going to be fresh in my brain. Okay, so we can't auto fix these things. Oh, these are in the value resolver. Okay, let's go into the value resolver and let's do a cargo clippy fix here. Okay, not too many. Yeah, that makes sense. That was a dumbass thing to do, right? This is the stream of consciousness programming when you just copy and paste things And so this is get us bool is obviously there's like get us int and get us whatever, right? So it's just copy and paste of the test, and those things goes missing. Don't need a lifetime there. To resolve expression. Then I'm okay with that. Yeah, that lifetime is probably just used there, which is why it's fine to get rid of it. Get rid of unnecessary references is good. Don't need to dereference the state. That's also good. That's implicit return. We don't need that. Don't need a reference there. Again, it's copies of other functions which has led to that. So it's a nice cleanup. So, okay, yes and no, Murlo. A couple of things where it differs. I have taken a single pass layout approach instead of multi-pass. So HTML combined with CSS and other nightmares is a multi-pass layout, meaning you do several passes through the tree to perform the layout. Obviously, that's very familiar to a lot of people, and there's nothing wrong with doing it that way. But instead, I looked at what Swift UI and Flutter was doing because they are single pass layouts. So they have a different strategy to doing things where you have a constraint that goes in and a size comes out, depending on what your widget is. So let's say that we have, let's say that this is our screen, right? It's a very wide screen, okay, which is broken in the corner. Now, if I just want to write the text hello, then I can lay it out here in the corner. I'm gonna get this entire width here, width here and height here as my constraint. But since hello is just 5 characters, regardless of you know, maybe this is like 8, what would it be, right? 100, say 100 by 50 is the constraint in. So saying you're allowed to lay this text out inside 100 by 50 cells. The text is only 5 by 1. It's 5 characters long, is the word hello, and the height is 1, right? So we get that constraint in and we return 5 by 1 instead, right? Then you have things like alignments. Let's say you want to align something in the center of the screen, right? To that, you need to find the center point. So you're going to take the entire size of the screen to do that layout. So if we're going to align in the center the text hello, then the text is 5 by 1, but the alignment is 100 by 50, right? So what this means is you have constraints. Constrained, I should have not written the whole word out, right? Goes in, and then you have size, which is a lot shorter word, goes out, right? And then you position and paint, right? So I have taken that approach to do this, which is a little bit different. We are working with a node tree. Widgets are marked as dirty as state change. I will run this in a bit and show you how this looks and how this behaves, right? But when you make a change to a state, which maybe would be more akin to React than HTML, right? You make a change to a state, any widgets that are using that state will subsequently change, right? To give you an example of how this works, right? Let's say that we have let's get rid of all this stuff. We can keep the parent. Let's get rid of this though. We don't need any of that. And let's just have a parent widget here. And whenever we get let's see, we can grab a key press, right? Whenever we have a key press on here, we need to get a state to this thing, right? So state is a string. So we're going to say state dot to mutable push the let some is key.getChar, right? This is just a shortcut for saying if the key input is that of a typed character, right? Then we're gonna push this character to our string, right? So this is all we have to do to do that now, right? Whoops. That's all we have to do now. So we have a mutable string that we can mess around with. And if I run this, you can see it says hi there. Let's go to our markup and let's say that we have our text, all right? And all this thing is going to have is the state. So now there's nothing there until I start typing, right? It doesn't have focus. I forgot that I was in the wrong. Let's do this. Let's change you to parent instead. And inside the parent, this is where we do this. Okay, I was in the wrong template. Text state. Very simple, right? Run this. I'm typing. It ends up there, right? If I say I want to have a vertical stack and I want to have many widgets in there, right? Now everything is affected, right? So every time I press a character, we will find every node that is interested in this string, this character value. And then we go and mark that in the tree as needing to be reflowed or laid out again. If that widget subsequently changes the size of its parent, then the parent will reflow and it will propagate down, right? Which is why making changes to certain widgets has no impact whatsoever, right? Let's say that we wrap every one of these inside a border that has a width of 20 and a height of 4, right? Let's say we did this instead. Now, when I'm typing, this text is not affecting the border, so it will not affect the vertical stack. So the only change propagation that is happening is to this text, right? That's how this works. And we do have a tree for this. We do have a tree for this, and the tree contains the layout. It contains all the widgets, right? But unlike HTML, well, actually, correction. Unlike HTML combined, and unlike a document object model, a DOM combined with JavaScript, in JavaScript, you can manipulate the DOM. You can insert elements and so on programmatically. That you cannot do here, but rather you use this to describe what your layout actually is. So if you, let's change the state to be more complex, right? And we should learn how to spell complex in the process, right? So before our state was a string, now our state's going to be complex instead. We can still have the string there, right? So our string is a value string. We're going to implement default for this thing as well. Actually, we're not going to do that. We're going to implement the complex and add a new function to this instead, right? So a string can be a new string, so it's empty, and we're going to make that into a value. We can also have a list in here. So that'll be a value of a list, and let's just pick numbers for now. Right? Could be numbers, could be strings, could be other complex states. Not recursive self-referential types for obvious reasons, but you could have a more small state here that has a value that is a value u32, and if you wanted to, you can put small state here if small state implements state, right? So now this will not compile. Well, this will not compile for the wrong reason. If I want to do this, then I have to say that this thing is also a state, right? And now this thing is okay, right? Well, we're not going to use a list of small state because we don't want to declare a bunch more states in here. We're just going to do this. So list can be a list from iter 0 to 20, right? All right, so now we changed that. This state here now refers to the string that we have to get a mutable reference to do something with, right? And then here, this will just be complex new instead, right? Okay, well, that's just going to show composite. Well, we can still run this thing. This thing works with hot reloading, which is why you can see this thing changing as I make changes. There's a thing. If you wanted to, below here, we can now say for value in state.list and then val, right? And there's all our string values in there as well, right? So if we want to do things, if I want to manipulate the state, right? Let's do this, right? Let's open up the main function again. And let's say if the character is the minus sign, then we'll do we'll do state.list.remove 4, right? We just remove some arbitrary value from the list, right? So typing and then pressing minus is now removing values from the list, right? So you describe the layout, and whether elements should be added or removed or not is entirely based on the state that you have. So rather than reaching into a document, which incidentally we do have documents, but rather than reaching into a document and manipulating the tree, we're instead saying, here's what you should do, and here's the data to do it, and then you keep track of how things should be added and removed, right? So yes, it's a little bit, yeah. Yes, we have a DSL for it. It looks very similar to YAML. It's very succinct. We don't have functions yet, but that's in the making. You can add more custom components, right? So if I wanted to add a component to something like we did here, right? We had one called parent, one called grandparent, and so on. You can send events between components. You can publish data. You can do everything. You can run this in an async context, or rather you run this on a separate thread and you can send information into this through async context. So if you're running like a network thing over Tokyo, you can use an emitter to send values into the UI. So you have access to the runtime from the outside, or rather you can communicate with the runtime from the outside. You can also communicate with the runtime on the inside, but you don't have to go the complex route of doing that. So yeah, there's a lot going on here. You can do a lot of things with this thing. You can describe background to be black. It's going to be hard to see, but the slight change there. The foreground could be red if you wanted to. So another benefit of this thing is that you can ship the templates with your program, right? So if I give this program to you, you don't like what it looks like, you can just change this however you see fit, right? We can make a theme here if we wanted to, right? So let's say that the background is red. So I'm going to say that my background here is actually theme.bg, okay? That's the foreground. So let's call that FG instead, right? Now, if, oh, right, what did I break now? Why is it not red? I don't think we have to use strings like this. That doesn't sit right with me. We should be able to say .bg. Oh, right. FG, BG. There we go, right? And if you don't like that, you can make it blue by just changing the template. As a matter of fact, let's do this, right? Let's get out of here and let's do a cargo run. And I'm going to break this. I'm going to run this now. The demo. And I'm going to break this up. I'm going to go to demo. I'm going to open up the template while this is running. And I'm going to say, I don't want blue. I want some kind of red, yellowish color, right? And I want to tweak this a little bit, make it maybe a little bit brighter there. And I want to tone down red a little bit as well. Maybe make this one a little bit brighter, right? You can do this while it's running because of hot reloading. And I can do this without having to recompile the program either. It just works, right? Famous last words, it just work. I did Mango, and I thought it was broken. Like, I thought it was a bug because obviously I'm infallible, so there must be a problem with the program, right? So yeah, and if you want this to go horizontally instead of vertically, bam, there you go, right? Again, while the program is running, okay, we can say that every one of these things lives in a container. Actually, let's make a horizontal stack for every value, right? And let's go back to making this vertical again while it's running. Okay. And let's have an alt background to be black and a background to be white, right? Or maybe dark gray. I think it's fine. So we're going to say that the background here is going to be theme dot background. Okay. Actually, what we're going to do here is we're going to have BGs. We're going to have multiple, right? We're going to have a black background and a dark gray background. Okay, so forget that one. Instead, we're going to say BGs here. BGs 0. Okay, now it's black. 1, now it's gray. But that's stupid. So instead, we're going to say, take the loop iterator, which comes from the for loop. So it's a special value called loop, modulo 2. And now we got alternating colors, right? Very simple. But this looks a little bit naff because it doesn't kind of like go all the way there. So since this isn't a horizontal stack, we can just put a space in there and then bam, there we go, right? It's incredibly easy to work with. You can change a lot of the things if you want to. Let's throw another border around here. If we don't like what the border looks like, we can change the border style from thin, which it is now, to thick. But if you don't like thin or thick, you want to give your own, right? You just specify a character for each section of the border, starting with the top left, top right. Well, when I save this, you'll see what it looks like, right? It's a bit painful to read. So let's just do something basic here, right? So we're going to have plus for the top left. We're going to have minus for the top, plus for the top right, a pipe for the right, a plus for the bottom right, a dash for the bottom, and a plus for the bottom left, and finally a pipe for the left. And now we have a border that looks like this. And there is a lot of ASCII border characters out there. You can build as fancy a border as you want to, right? Box drawing characters. There are loads of them. You can grab these for the corners. You can just copy these straight up if you wanted to. I mean, we could make everything into this weird lump if we wanted to. It's just, you know, the sky and a very limited character set is the limit, right? For this. So there's a lot you can do with this stuff. We want to change the foreground on the border. We can do so, but we don't want to change the foreground on the text. So the foreground here is going to be reset. Right? Maybe we want it to be white instead. Maybe we want it to be bold so we can see it better, right? Like, again, there's a lot that you can do with this stuff, right? Three nodes did use RC RefCell stuff. No, Murilo. And I'm going to tell you what I did and what I recommend that you do depending on how you're going to use the tree, right? So normally what you can do with a tree like this is, let's say that you start off with a root node. Root that has a, I'm going to base this on Perkins tree from earlier, right? That has a value and then it has a left node. And it has, you know what? I'm just going to write L and R. I don't know why I'm trying to even draw characters, right? So root, there you go, right? It has a left and a right. And in memory, this tree, it will possibly look like someone took a shotgun to the memory, right? So let's reset this thing. Actually, let's do this. I'm sorry, Temporis. I'm going to use Excalidraw here. All right, just to show this off. All right, so this is what we worked on today. This is now sold by. All right, let's go in here. Okay, so let's say that our tree looks a little bit like this, right? You have a node, and this node is connected to another node, which is connected to another node, right? So this is going to be the left node. This is going to be the right node. And of course, this in itself can be the right node maybe of this tree, and then the left node is empty, right? Now, when you lay out things like this using the RC RefCell stuff, what you end up with is all of this stuff in memory could be all over the place, right? So instead of doing it this way, the way I laid out the tree is I took one large chunk of memory and I put all the values in here. Then I took something very small and call it the tree layout. And this stuff is tiny little indices instead, right? This is going to be hard to draw with this as well. How it's laid out. Okay. So the layout of this thing looks maybe a little bit like this. And let's get some arrows in here as well for good measure. Because it's not tiny. But this is just the tree structure, like the tree layout. All the values that we operate on are stored in contiguous memory. So if you want to go through everything in the tree, that's actually really fast, right? Telepathy, bomb deal, right? So you don't have to do the RC ref cell. Instead, let me show you a very, very basic tree. Can you query for a particular? Yes, and that is also really fast. I think we tried like 30 million entries in the tree to find a specific node, and that was... It was sub-millisecond at least. I wonder if we were somewhere in like 290 nanoseconds or whatever. It was very fast. Let me show you a very basic tree in Rust, the way you can do it, okay? So the conventional tree would be a node of T, where you have a value that is T. You have a left, which is a box, option, node T, right? Now, it has to be T because it's a homogeneous structure, right? You can't store... Well, I mean, you know this, right? Okay. Now, because of the way you phrased it using RC ref cell, I'd imagine that you would have something like this. RC, and instead of having a box, it would be an RC ref cell option, right? Because we have to be able to mutate this thing as we go along, right? So it would look something like this, right? So this is one way of expressing it. However, what you can do is something like this instead. You have a struct called tree, and then you have the data storage for the tree. So the values would be a vec of T, right? Now I'm going to simplify this a little bit. Yeah, so let's sort of simplify this a little bit. If I can just get my hair to not try to strangle me. And then we have the layout of the tree, which could be a vec of node, right? Notice that the node does not have any generic values. So a node looks something like this, right? Now, there's an obvious question, what happens when I delete something? We're going to cover that, right? So the node has a value, that's a usize, okay? And it has children, which is a vec of node. In this example, you would have children here, right? Which would have something like an RC ref cell node, maybe, kind of thing, right? All right, we can't call that node because we call this thing node, but there we go, right? So if I want to get a value from the tree based on a specific node, then I just get the node out of the tree and I get the value ID, right? So to get a value, you would have a node.value, which would go to tree.values, node.value, right? So you would use an index here to point into this instead, right? That's gonna make things a lot easier, okay? Well, yes and no. We're not gonna use usize, okay? Usize is a little bit of a sneaky one, right? Because obviously, let's talk about what happens when I delete a node, okay? So let's create the tree here. Let mute tree is a tree. We're gonna have value, values in plural, all right, and layout. So our values can be a vec of nothing, right, an empty vec, and our children can be the same thing, an empty vec, right? And semicolon there. That's layout. Values and layout. Layout. Come on, brain. Layout. Okay, we haven't given this thing a value yet. Let's just, well, let's say that we store strings in there, okay? We're going to have something in there. Right? So let's make a function for the tree. So impl tree insert or add or push or whatever, right? Add, and then we're going to have a, actually, how we add things is also more complicated, right? The way we get, let's start with that, right? So a tree node path. All right, there we go, right? So to get something out of the tree, we can have, there's two get functions here, right? We can have a path, which is, so I'm using U16 because one branch of my tree can never be more than 65,535, right? Because I'm never going to have that many widgets in the tree. If that exists, then something else is wrong, right? But for simplest sake, let's just have a slice of U size, right? So this is how we're going to get a node from the tree, right? That will return a reference to a node. And then we say, we do something like this, right? Let's match on the path. If the path is the index that we're looking for, and let's have nodes here, that's going to be self.layout, although we only want to reference to that. Note that I'm making this mutable because we're going to change this over time, right? So if we end up with I here, we're going to do nodes I, right? That's how we get the node out of there, okay? If it's more than that, it's going to be I like this, and then we're going to say that our nodes is equal to nodes I and then children, right? So you kind of see how this works. So we just scan the tree, and the keys to the nodes are just segments of paths, right? So we're just going to scan the tree and get values out of the tree that way. Now, we should be using an option here, right? Because we could arguably get things that don't exist, right? Yes, we should obviously, right? Hang on 1 second. I need to link the mandatory video. There you go. The mandatory video on how to build a slab in Rust. In this case, we don't deal with an incorrect path, right? So to do that, you just make this thing into an option and you check these before you go on, right? But we're keeping it simple now. Why wouldn't that work? Nodes is a vec of nodes. There we go. All right. Oof, okay. And then if we're here, then we're going to panic. Invalid path. All right. Again, we're skipping the option thing. We're keeping it simple. This is actually a really fast way of digging into the tree, right? If you're digging like 3-4 levels into the tree, that's 3-4 index lookups. They're effectively as fast as a pointer dereferencing, more or less, right? And then if we want to get a value, we just take an index in here and we return a reference to a value, right? Okay. So, and obviously you can shortcut this. You can have a get value by path and take a path in instead. So we're going to get the node. Get node by path, and then we're going to do node of value, right? So we can get a value from a path as well, right? And this will definitely be fast enough for most likely what you want to do with the UI, right? The cost in performance in the UI is probably going to be mostly dependent on how your layout algorithms are. Yeah, we have performed layouts on many widgets that has a lot of these things, right? You have to know the path to get the node. Yes, but when are you not going to know the path, right? That information is going to be available to you when you want to do something, right? So let's say that you want to do a layout, right? Then we get the root node. Actually don't know what the root node would look like. That my layout is a little bit different, but you'd start on the tree to just do layout. So you lay out everything, you lay out every node, right? You just go through the nodes and do layout. If you don't need to do that, if you can perform a layout directly on the values, then that's even faster, right? Because the values are stored in contiguous memory. You can just load all this stuff up into your L whatever cache, and then you're off to the races, right? Yes, you are always going to have to know. And here's the thing, Murlo. Here's the thing. If you ever need to store a value on some other struct, right? Let's say that we have a struct called a thing, and it's going to have a value. All you do is store an index into a value, right? Now, the ridiculous video I linked to above will explain how to build a slab if you don't already know that. And once you know how a slab is and how it works, then you would just replace the vectors with slabs for the values, and you're off to the races, right? Because that gives you stable memory position for values, even if you remove a value, right? So instead of, we could think about it like this, right? We can make a very naive one here, right? Values. And in here, we're going to have a vec of option t instead. And we have a free list here, which is a vec of usize, right? So when we go to remove something here, what we really do is we do self.inner .take index, right? That's what we're going to return. And then we do self.freelist.push index. So this is a very, it's not take. Oh, right. Index take, right? Oh, goodness, brain. Brain. And when we go to push a value to this thing, we will return the key to the value, self.inner. Well, before we know where we're going to push this thing, we do this, right? Match self.freelist.pop. This is not the slab. The slab implementation I have, the keys are not stored in a free list. We don't need multiple allocations for the keys, but this is a simpler way of doing it, right? And there's nothing wrong with doing it this way. Okay, so this is going to be our index. So if we do get an index here, we're going to go self.inner index.set value. If it's none, then we're going, oh, and of course, we're going to return the index here, right? And if we don't find a value in there, then we do simply the index is going to be self.inner.length. We're going to return the index and self.inner.push value, right? And now we have replace some value. Whoops. Some value. There we go, right? So this is a very like a naive implementation, but you can sort of see how this works, right? go for it, Londo. I mean, why not? You got to do what makes you happy. So it can't just be about the spreadsheets. It also has to be about wanting to build it. So in this kind of more naive implementation, we can just push values and we get the key out. So when we go to insert something into the tree, now, this is where things gets a bit complicated. I'm not going to fully implement this because it would require us to implement traversing into a given path and doing a bunch of stuff there. Actually, you know what? Why don't we do that anyway, right? So let's say that we want to insert a value at a given path, right? U16, please. No, we changed it to usize for this conversation, right? Value t. And we're going to change this to get mute instead, because we want to be able to modify this. And then obviously, so now since I ruined this thing, we're going to have to change this to get node mute, which requires this to be mutable, even though we're never going to do anything with it. Wait, what are you griping about? All right, stop borrowing things. Rust. There we go, right? So now we're going to insert something. The first thing we're going to do is find the node that we're going to insert this into, right? So that's going to be a parent. Let the parent equal self.get node mute. And so the path is going to be to the parent, right? If you need to insert at a given location in the tree, you can do that as well, right? You just have to, you can work that out. I'm confident, right? So parent.children.push a new node, right? And if we say that the layout, the values are values t instead, then we'll do unwrap there because I'm lazy. We should definitely not do this, but I'm doing this again because I'm lazy. And then here, we're going to have to set the value, right? And what is the value? Well, we're going to get to that in a second. Children is just an empty vec. Like that. And close that. Okay, so inserting, now we need to create a value that we're going to insert this into, right? So the value ID, or we're just going to call it value. Well, actually, let's call it value index to be really explicit, right? So self.values. Is it push value maybe? Yeah. And now we have the value index here, right? So you're always going to end up values. Let's just do values default. That'll be the easiest thing to do here. So I don't have to implement a new function. Oh my god, what do you want from me? I'm so needy, Rust. Right. Yeah, why this isn't borrowed more than once? What are you griping at me for? This isn't borrowing values. All right, the compiler is broken. It's clearly not me. Oh, right. Okay. Yes, it is. It is me. So we have to do that, right? Obviously that's going to be me, right? This is because we have a function call that is mutable, right? And that's it, right? Really. So there you go. You can add node from the tree. Can you have a node method to add a new node? You could, but you don't. If you don't store the values with the node, then you have to go through the tree. Now, in my incarnation of this, we have a lot more, like the tree is actually kind of complex at this point, and it doesn't have to be this complex. But if we look at what you can do with the tree, actually we should go to the tree view because that's the more commonly used, right? You can do everything from applying visitors, check if something is contained, iterate through each value, although I don't know why we have two of these. I don't even want to look at that. Various get mute functions, but more importantly, you can actually split the tree into a smaller view of itself, right? So if we have the entirety of the tree here, we could break the tree into this that also contains a mutable access to all the values, right? We do this to symbolize the values, right? So in doing that, yes, we can manipulate a branch of the tree and have access to the values as well, right? None of this has any RC or ref cells. As a matter of fact, the only RC that exists in the entire project is something to do with values, the way they are stored when they are currently borrowed. Cool. Wow. The tree is the main namespace where user interaction happens. Stuck with the HTML way of thinking. You could think about it like that, right? The way you don't have to think about it like this, but the way I like to break down my tree is to break it into two components, right? One chunk of contiguous memory where all the values are stored in the tree, and then the actual layout of the tree, right? That's like a really beautiful tree, right? Where things are stored. Now, getting through these nodes is actually quite fast as well. It doesn't take a lot of time to navigate the tree, right? To go from here to here is just 1, 2, 3, 4 jumps, right? Now, if this is the root node, then really these two are just part of a list in the root, right? So in reality, you don't make the first jump to the root node because the tree doesn't start with a node. It is the root and starts with children, right? But that's my setup, right? So this is really just 1, 2, 3 values. That is 3 lookups inside a vector, and doing a lookup in this contiguous memory is really fast, right? You can go quite deep without it being an issue, right? And then once you have the value, it's going to point into one of these things. But more importantly, why do you need the value, right? I'm not asking you to justify why you need the value, right? Instead, I'm saying like, why do you need the value? It could be the case that the value you need that somewhere, right? And that value would be just a key, right? So you don't go through the tree to get to the value, right? You're already going through the tree to do something, so you might want to look up the value. And now you can store a reference to this value through something by just giving a key, right? You can somewhat achieve similar things with RC ref cell, but they can be a little bit unergonomic to deal with as well, right? Hello, Michael. How you doing? Let's say I want to change position inside an update loop. So this is a little bit how you think about your data, right? If you think about your data as something, let's see, how can we talk about this then? In my tree, all right, let's restart this. Because I can really, I mean, I can't, but I am talking about this from my perspective, right? In my tree, all the widgets are stored in here, right? All the elements or the nodes, right? They're stored in this list here, right? So when I go through, when I'm looking at this widget here, maybe, I know the children of this widget from the tree structure, right? So if this thing has a bunch of babies, right? I don't know, before I drew the tree like as if it was a binary tree, but it's not, right? You can have multiple babies to one node. And all these are going to point into various values here, right? They are fast to look up. It's not an issue, right? So I can just use this list if I want to do a layout of all the children. And then it's happy. This kind of looks like a bag and a virus at the same time. So why do you need to know the values? Because you might want to perform an operation based on that value, right? But a value reference could just be an index. Actually, I don't know why I told you that. We are past that conversation. Very much so, right? But you might not think about your tree in this way, right? Let's say that you store all your widgets like this, and you have your root node with some babies here, and stuff. This is just an alternative, right? Let's say that what you store in here is one type of values, but what if you want to group your layout data in one place, right? Let's say that your layout is just rectangles with positions and sizes, okay? They don't have to be stored with the widgets. That could be a completely separate tree that can have a size, a size and a position. We'll just draw X and Y here so I don't have to write anymore, right? But on top of that, they can also have the widget ID, and this widget ID can point to a widget. And this widget can point back to this thing, right? Through the indices, right? Sure, you can do a lot of this stuff with RC-ref-cell. You absolutely can, but RC-ref-cell doesn't necessarily put things together in memory, right? Let's say that you got these three widgets all stored together in this chunk of memory, okay? And that these widgets are very small in size. That means that by the time you've gone from L1, 2, 3 RAM all the way back up to L1 cache, now this is a happy caterpillar, it isn't, all the way back to L1 cache, you have all three values there. So when you perform your layout, you don't have to load these two values. They are just offsets into that memory, right? But if you use RC-ref-cell, or the RC part of this thing, right? You have no chance of necessarily, you could accidentally, but you could just as well not accidentally store things in contiguous memory, right? I've had so much water. I need a quick bathroom break. Hang on to your sockets. All right. And then we're going to maybe push this to main. All right. Okay, you know what, Murlo? This design here gets rid of that borrow checker rule, right? If everything is an index into a list, then all you have to do is just query the list, right? You shouldn't have mutable access to the same thing twice anyway, so it's a bit of a non-issue. Now, there are situations where you need mutable access to two different regions of the list, and I have a way around that as well. That I have that I called something like a ticket list or whatever. Don't know if I did a video on that, but it's reasonably simple to understand. As a matter of fact, I'll show you how you can get around that too, right? So let's make a new file here, and then I'm gonna do some actual productivity stuff here, right? Let's make a list RS file here, and let's have a pub struct list t. And again, we have the inner value, which is a vec of t. And if I want to get two mutable references out of this thing, I can't really do that because I would end up borrowing the list mutably twice, right? Let's get a main function further down here so we're not distracted by the trees and all the things there, right? So let's make a new list here. We're going to do list.push 1 and 2. And the goal now is to be able to get access to both of these values, right? So let's quickly do an impl list here. Let's have a new function. And inner is a vec. And let's have a push function. Value. Very hard to write that apparently, right? Self.inner.push value, right? And let's bring this in, and all is well, right? Now, but here's the thing though, right? We wanted to be able to borrow from this list twice, right? We want to be able to have one being list 0, mutably at that as well, right? And 2 being list 1. But if we try to do this, then this thing will obviously yell at us. If we make this public, we can see Rust in all his glory here. By saying inner here, and if we try to print out this where we have 1 and 2, right? I don't know why I added a pipe and a comma, right? But it's not possible because you can't borrow from the same thing twice for obvious reasons, right? There are so many reasons why it would be a bad idea if we allow this thing, right? Anything from the memory moving or being copied to another region and validated on account of capacity, whatever. That's beyond the point of this thing, right? But let's say that we don't have a vec t instead. Let's say that we have something called an enum entry t instead, right? So this one has a value of t, and this one here is checked out, right? This could be represented with an option, but I'm trying to be a little bit more explicit. So we're going to have entry t here instead of just having a t. So when we push something, there's going to be an entry has value of the value, right? Okay, Rust, calm yourself. We'll get to you shortly. There we go, right? Stop it. There we go. So when we push something in there, but what we can do now is we can check out one of these values, right? So we can have a function here with value, takes a mutable reference to self, and it's going to take an index to the value that we're interested in, and it's going to take an f as well, right? So here we have to be generic over f, and we're going to get a little bit rusty here, where f is a f and mute that takes a mutable reference to a value, but it also takes a mutable reference to a self, right? Which might sound a little bit insane, right? So let's get the value. That would be, now hang on, this isn't right. Yes, this is right. Okay, so the first thing we do is we're going to check out the value, right? So let's make a new entry here. That's going to be self dot, no, it's not. It's going to be entry checked out, and we're going to swap the memory now with the entry. Wow, thank you, Kugelman, for the raid. Welcome, raiders. With self dot inner index. Okay. So what we do is we kind of take the value out of the list and replace it with a placeholder. Then we're going to use the memory with the, right, then we have to match on the entry now. And if this entry is already checked out, then we're going to panic, right? And say invalid state. How's the game? How's the stream, right? And if the entry is what we're supposed to have, which is a hash value, then we are ready to continue with what we were doing, right? Which in this case is going to be to call the function with a mutable reference to the value and subsequently self. Once we are done with the function call, we're going to put the value back. So we're going to take the self.inner index and say you are now an entry with a hash value of the val, right? And have enough colons there, right? That has to be mutable, and that has to be mutable, and that's it. So now, if we wanted to do this, we would say list.widthValue, and we're going to get index 0, and we're going to have the value in question. That will be 1, and then we're going to have the list in this function, right? And then in this function, we can do list with value. We want to get the second one, which is going to be 2. And again, we have full access to the list as we do this, right? And now we can just run this code here. So if I run this, there's our 1 and there's our 2, right? So we effectively have mutable access to 2 things that belongs to the list. We never take them out of the list. Well, we do, but we put them back before anyone noticed, right? We never remove them permanently from the list. Well, yes, we do. But again, we're going to put them back before the closure ends, right? So the only way that you're going to be able to do something with these values is have a mutable reference to them and do something with that. You don't actually get ownership of the value, right? So through this function, we put it back, right? Oh, it's just years of arguing with Rust, Murlo. But the general idea here is that what you want to achieve is most likely either possible or a bad idea. I'm not saying this is true across the board. I'm saying that there are things that you might want to do, and they might seem to offer a little bit of friction at first, right? I mean, this is obviously a lot more typing than this is, right? But the problem, if this was allowed, the problem is that we could invalidate memory addresses where these values live, okay? We could literally change the list if we wanted to now, and we would not invalidate the memory because we use the indices, right? So let me just poke at that with a little bit of a stick in the beginning, right? Let's say that this list is a list with, let's say that this thing has a capacity of 2, okay? So when a list has a capacity of 2, that means that we can store 2 values in that memory region, right? With the first place and the second place, right? We don't know what these memory addresses are. I mean, we do, but we don't have to care about them, right? So I've put 2 values in here, right? Just going to draw a value, and now I want to add a third value to this, okay? But I can't because the list is too small. So Rust is going to say, okay, you want to add another value, it's too small. So what I'm going to do is I'm going to find twice the memory that I have, 1, 2, 3, right? And then I'm going to take this at memory address, say A and 0xb, terrible memory address. But I'm going to take that, and this is going to be somewhere like, let's say 0xff. These aren't valid memory addresses that, right? Yeah, well, you guys understand that, right? And we're going to move the value here and that value here. And then we're going to insert the new value here, okay? All is well. However, if I have a mutable reference to this guy, right? That means that I have a mute. Wow, that was almost legible, right? A mute to 0xa, right? 0xa. The problem is that this guy doesn't live at 0xa once I push. So the memory that I have a reference to at 0xa could now contain something completely different, right? This guy is still going to live at index 0 no matter what we do, but is not going to live at this memory address though, because we had to find more memory and allocate more memory, copy everything over there, invalidate this address or these addresses, and say that these are now the correct addresses. But again, the index doesn't change, right? This is why you can't have a mutable reference to something in a vector and push to the vector at the same time, because you might end up invalidating all that memory as you move, right? So yeah. Thank you, Kleptomaniac. I have practiced a lot, right? Handwriting. Okay. So what might seem like a trivial and frustrating thing in Rust, you might look at this thing and go, why, you stupid language? Why are you not letting me do this? That's because list.inner.push3 could invalidate both of these memory addresses, right? So when something doesn't work in Rust, there generally is a good reason for it, but we can work around that. So instead of saying we have stable memory locations, we have stable indices in a collection instead, right? But anyway, we are going to get back into trying to release the software, the library we're working on, right? Am I using Arch, by the way? Of course I am, right? Do I not look single to you? I assume this is Hyperland. No, Hyperland gets the girls, all right? We don't do Hyperland here. No, this is I3. Let's get rid of the tree and let's get back into this thing. Feel free to ask questions, Murlo, if you ever want to get like into wrangling Rust or whatever, right? There aren't really much to my dot files to share, but I'm using the IU Mirage terminal theme and my own for Vim, and that's available on my GitHub, which should be linked into the linked in the description. Comment and smash a bell. I don't know. It should be somewhere. If not, once the bot is up, we should be good, right? No, the bot is down. The bot is down. Yeah, but Scott, didn't you get married before you started using i3? Let's be honest now. No, we have those, Londo. It's just that I broke the bot. That's why they're not working. Okay. All right. So it's okay. Tests are running. Tests are passing. What was Clippy doing? So cargo Clippy. Oh, that's what we were fiddling around with, wasn't it? All right, so let's do git add -p. So we're going to patch things in. Yes, we're happy with the Clippy's changes here. I thought it did all this, but maybe I stopped and then went on a tangent. I tend to do that. This is clearly test code, so we don't have to be too worried about that. Yeah, those are the asserts. They're good. Good. All of them. I'm happy with all of this. Clippy, take my money. Just get on with it. So many things to commit. Okay. All right. Let's just run cargo clip in here. Can we not fix that? Ugh. Okay. Git commit. But rather than adding a second commit to this thing, we're just gonna amend the one that we have pending. Can you fix this clip? No, you can't. All right. All right. We have to go in and do this by hand. We have to handcraft fixes. Okay. Let's go to variables. Variable. Where is this thing? No, it's in the wrong project. Okay, so templates and then cargo clip. Fix this thing. I can read chat in the meantime, right? Well, thank you for that, Murlo. Thank you. You were using a Mac when you got married, and so was she. Do you were you both like faking for each other then, do you think? All right, and you can't fix that. Okay, we're going to patch things. You know what? I'm reasonably confident I'm going to be okay with all of these things. As you know what? As long as cargo test all is not broken, I'm good. All right. We're running our 360 something tests here. Back to templates. All right, all good. Clippy, show me what you got. Okay. Right. So, oh no, hang on. Passing a unit value. Oh, okay. Store. That's not even this project. Okay, we're off to the next project. State. Can Clippy fix these things? All right, we're just gonna do that. No. All right. I have to amend the commit. There we go. Okay, that drop unit makes no sense. Who wrote that? Who wrote this code? Okay. Where are you, Clippy? Tell me. 110. Look at that. All right. Not committed yet. What could have gone through my head? Oh, this is the clean this up. It's gross. Wow. Yeah. We have some to-dos that needs to be corrected as well, right? All right. Let's see. Okay, nothing there. Let's see. Cargo, Clippy, all. Oh, we still have some things in there. You know what we're gonna do? We're gonna do this. Okay, we're gonna take the lace away. To freedom. Okay, cargo, Clippy, fix. Okay, and let's see if we can fix more of these things. Oh no, we're done. We're done. The free fixes are over. We now have to handcraft our fixes, right? Handcraft fixed. London, will you participate this year, Enrico? For those of you who don't know what I just talked about, we're doing a relay. Well, I'm going to explain the relay later, actually. J'accuse. Is it wrong to assume that everything is movable? Say you want to subscribe to an event from some C API. So there are circumstances where there is a contract of memory not being movable. This is referred to as pinned memory, right? You can pin some memory, and while that memory is pinned, either on the stack or the heap, you are not allowed to move that because that would be undefined behavior, right? If you broke that contract. But when other things are coming across FFI boundaries, foreign function interfaces, which is what you use. I'm saying this not for you. I'm saying this for people who don't know. That's what you use when you want to interrupt with some C code or whatever. Someone wrote the library. I mean, a lot of stuff that we're using on the computer is written in C, right? Like libc is a big part of what we're doing, right? And then Rust has all the wrappers around that for doing whatever this is doing, right? So there are a lot of FFI stuff happening under the hood. And or rather, Rust, the compiler, as opposed to Rust, my imaginary girlfriend, cannot make any assumptions around the C code, which is why we wrap it in unsafe, right? You don't necessarily know what foreign code is doing, so you should assume that any pointer you get might become invalid at some point, right? Like that's just a fact of it. Unless you have access to the code, you can inspect it and go, oh, I can see here that it's never being moved, but that is not a guarantee that the compiler can make, right? So if I were to get a pointer from some C code, I want to know two things. One, who's in charge of freeing this memory? Is it me, or is it the whatever's calling the function, calling the Rust function? Is that in charge of freeing it, or is it the Rust function, right? Most likely, it would be the C code that's in charge of freeing that memory, right? I would like to know that the memory address is valid, right? But once you do that, if you can safely prove these things, then you can wrap this in unsafe and give a safe Rust interface to this code, which is a very nice thing to have, right? I might have gone off the rails there a little bit, but I'm trying. Okay, cargo Clippy, what are we looking at now? There are quite a few of these things. Let's go to the runtime. And whoops, mod, please, cargo Clippy, and let's walk through these things, right? So runtime mod 276. That one's gonna do a return. Okay, so this is a no-op. It can be a unit because this this match statement is returning by default because Rust has implicit return. It's a beautiful thing. When you start programming Rust, either you love it or you hate it, the implicit return. But as I give it a chance, I personally think it's really pleasant to work with now. And it's a bit near when I can't, right? This thing is probably already a mutable reference. Yes, it is. So that mutable malarkey was just complete waste of time. Testing on line 70. This again, a type, something has changed type, right? So we don't need that because we already cast it here. That's going to be a 128. Yes, it is. We don't need that level of precision. Is not about precision. We don't need those big numbers, right? In our case, the timing is too sharp, right? Okay, the builder, Bob or otherwise, has what? The into is meaningless. Is that what you're saying? Yes, it is. Sometimes I even read the warnings, right? 108, similar issue. All right, things are being converted in using into when they were already that type. Again, these are like residual issues. Okay, so let's go to 20. Yeah, that's meaningless. That was probably done for debugging, right? So do we have other to do? What's that? To do nothing, right? Oh shit. Let's not deal with that now. But every time I do that, it's because I've had a breakpoint, right? So I would have done doc is this, and then return doc, and then I put a breakpoint there. Now we can't put a breakpoint there because we have nothing to actually run this, right? But it makes sense that these ugly things are here. I'm not justifying them being there. I'm telling you why I make these things, and they are the correct thing to do until they are not, right? Bounds are defined. Oh, hang on, I gotta read this one. Clippy the bush kangaroo. Okay, so we got back and there. Okay, so the thing is griping on is that we have this, and we have the trait bound on backend, and then we have the where clause as well, right? So it's redundant to have that. Okay, I think we are done with this particular project for our clippiness. Default widget. Okay, so let's go to our next guy, which is the default widget. So we're just gonna git add all this, git commit, amend, and actually we should cargo test all again. There's no reason why the test shouldn't pass, but you know, right? Rust. Don't trust the Rust. All right, text. This one needs to have a better text layout algo because it's not very efficient. Well, it's efficient, but I made it inefficient by copying something, right? Right, so here are U16s that we don't need. And I'm guessing that's the same, yeah. And then 88, we have what? What's the gripe here? Oh, that makes no sense. Wait, does it? Called map on an option where f is a closure that returns a unit type. Okay, right, so this is one of those annoying things with Rust and semantics in general. We're kind of using map wrong here, right? Map means map one value to something else, but we're sort of using it as a for each or an each or whatever here. But there is no other function for this, right? So I actually think that this lint is a bit stupid, but we're gonna deal with this either way. So we say if let sum text equals this value, and then we actually get less text, less code to deal with. All right. We're still gonna do this, and these Boolean operations are relevant to the closure we're passing in there, so they are fine. Let's go over the border to 98. Again, these are things that have changed type over time, so they needs to be cleaned up. For these things, I really like Clippy. Clippy has in the past been reasonably good. There have been situations where things have not been ideal when it comes to Clippy, but in general, Clippy is great. and all hail Clippy. They're not paying me to say this. All right. Let's do this. And again, more of this stuff. 262. Is this the border? Yes, it is. All right. I've lost track. So let's just run this again. Okay, where is this? Default widgets border 67. Cow. Right. From stir, we don't need that. That can just be cow. I have a habit of dereferencing and referencing things sometimes just automatically. My brain does it, and that's really annoying. I'm quite happy the Clippy is here to tell me how wrong I am. Very much like my wife if she wasn't imaginary. Cargo Clippy again. Okay, let's see. Border 88. Let's see. So we shouldn't return this. Again, implicit return. Implicit return. Are we done with the borders? Yeah. Okay. So we're going to get out of here. We're going to cargo test because test knows best. No, it doesn't. But at least we can spot instant regressions. I think the value resolver was the next one. I can't wait to see what mistakes I've done here. Okay. Let's go to storage module. That's not the strings thing, right? So this string crate is a way to store text strings that are dynamic or owned, like borrowed string slices or owned strings, because they're made from other types like numbers and such, right? In contiguous memory, right? I talk a lot about contiguous memory because there are benefits to storing things and retrieving things from contiguous memory when you're going to perform a lot of operations on them. And again, we use a lot of indices into these data structures to get these values and so on and so forth, right? And this crate here does that. If you think about how strings works in a UI library, right? You might have something like hello followed by a placeholder, which is supposed to fetch your name from a state and all that, right? But when you perform layout on this text, you want all that text available in one go. You don't want to have the text and then you want to resolve a value across some function somewhere else and do whatever, right? You just want that text to be able to perform operations on these text segments, right? And that's what this project does. It is currently not in use, and I don't remember why, so I'm gonna have to figure out why. There's only 3 tests in there, so that might have something to do with it. But it is a more efficient way than what I'm currently doing, but that doesn't mean a lot, because I'm doing something very inefficient here, right? Okay, so again, it's gonna gripe at me for using map the way I do. So let's do if let sum regions equals this. And then we're just gonna push this. But it is kind of, I mean, it's not worse though, but it's a little bit like so. Hello D3, I am perfectly capable of not being lame, but almost to my end, oh, forget it, just insert some kind of mom joke in there. You can work it out, you got the details. How you doing D3? 27 on the storage module. All right, so what is this thing griping about? That we don't need a lifetime. Yeah, that makes sense, all right? In Rust, well, actually, this is funny because we got 2 mutable references here. Or rather, we have a mutable reference to an immutable reference. But this thing probably looks a little bit like what we were doing earlier when I was showing off the paths, right? Yeah, D3, sort your shit out, man. Be cool, man. So what happens here then is... yeah, we're taking something out of there, and we don't need a lifetime here because we don't return anything, right? If you have a function that returns something in Rust, okay, ret something, right? You don't need a lifetime, right? Let's get rid of this window because it's annoying, right? We don't need a lifetime here. If we have one input. And we have, well, if we have one input, we don't need a lifetime, okay? Because this thing comes from outside of the function and it will outlive the function call, right? So we don't need a lifetime, okay? Well, I mean, that's kind of partially correct, right? We still don't need a lifetime. right? Let's return something here, okay? Now, we still don't need a lifetime in this function, in this function signature, right? Because there is only two different lifetimes that we can have here. Either a static lifetime, as we do here, by returning whatever this is, or the lifetime of A, right? And a static lifetime is always going to outlive or live for at least as long as A, right? However, when we have another reference in here, now we need a lifetime, right? Now we need a lifetime because we don't know, from looking at the function signature, we don't know which reference we are returning, right? Is this A, B, or static? Now, you can see that it's A, I can see that it's A, but what if this was a trait? And traits don't have function bodies, right? So we have to help Rust here a little bit, right? By giving it a lifetime, right? We can give this a lifetime, and now the only thing that we can return from this function is either a static value, like so, or A. If we try to return B, we're gonna get it in the neck, right? So why am I telling you this? Because I had added a lifetime, but lifetime annotations can be really helpful to know what the meaning of something is, right? So when we name things A prime or tick A, we are being a little bit lazy, right? I am very lazy. Okay, so we don't need the slice lifetime up here either, right? So this, again, this is purely been for, I don't know what reasons, but this thing here is going to come from the slab more than anything. Actually, this is a little bit weird. Well, this lifetime has to outlive the slab, so it's not that weird. So A, whatever lifetime of the string size, is, it's either A or longer, right? Ugh, that was a lot to say, right? Cargo, Clippy. All right, and let's have a look. And find out where the next thing is in the region. I kind of want to review this code and see what's what here, right? Try len. Right, so the length is already a use size. Now, here's a nice Rust treat for you, right? If you're not familiar with this thing, this has been referred to as a Mara slice because the person who brought this up is Mara Boss. She is quite active in the Rust community. She wrote a book called Rust, Locks, and Atomics. You can read it for free online. It's pretty good. But this is kind of a nicer way of writing. So let's just take this code, right? This is sort of a nicer way of writing this, right? Self.start as use size plus len, right? So we're kind of making, and you're not going to see a performance loss here, right? There was someone on Twitter, obviously, that had some comment that in some circumstances there might be slightly lower performance, not performance you're going to notice most likely, right? But which one do you rather read of these two, right? So this one will get us a slice that starts from a given position, and then we get a sub-slice from that slice that ends at a given position. Whereas here, we pass in the full range, right? So the Mara slice is a lot more convenient to read, right? It's a lot more nicer to read. Okay, line 10. This is a... Now, hold on 1 second, Rust. Is this really true? Yes, it is. All right, so let's get rid of that and surround you with square brackets, and it's fine. Sometimes you need a mutable reference to a vector because you want to add values to the vector. In this case, it's a slice, and we're only borrowing values from that slice, so we don't need to add anything, right? So that is a very valid clippy lint right there, and we're done. We've clipped it up, right? Git, add everything. Let's do a cargo test all as per usual, because we're messing around with stuff that I haven't looked at for a while, so I'm going to be a little bit rusty. No pun Nintendo. Okay, so let's do a git amend to get that in there, and let's go to the next one. Again, we are very close now. We are... Ooh, Nelly. Ah. Right, we need... Ooh, no. No? Are we done? Are there no more clippies to be had? And everything more. All right, that was another thing. I think we're done. We have everything done. What about cargo test? All. No warnings, no nothing. So I have for the last few days of commit free. I say few days. Trying to say the term right. Git push. The last for last 7,000 years, I've been getting emails telling me how I broke the build. Now I am hoping that we are not going to see a broken build. But if we go to GitHub, togglebit, and anathema because someone had taken togglebit already, and we're going to look at the. Can we look at the action? There we go. Right, let's see if this thing is actually going to pass. Right, you can see how I have broken the build for a long time, right? It continues all the way into next year, okay. Can Rust Analyzer do inlay diagnostic for lifetimes, leaving the scope at the end of function body yet? I have no idea. I have no idea if it can. I don't remember, right? Now we have to green tick if we're gonna merge with main, okay? We cannot have, yeah, see, I broke the build again, right? Oh, apparently the test is broken. Oh, what sordid thing have I done? Where are you broken? Wow. Absolutely wow. This should be a no-op. Okay, let's go and look at the store change. State. Yeah, okay. This one shouldn't be here. As a matter of fact, debug to file should be removed from pretty much everywhere except the macro itself, right? Debug to file. Okay, so we have that in the state, source, store, come on, subscribers, 3, 4, 5. Oh man, it's like doing maths again, right? Let's get rid of these things. They are debug for debug purposes only. As a matter of fact, they should be no ops though, since we don't have a default for debuggy, right? File log is what it's called now. We do have a profile in there, and I shall run that at some point. But let's see if there's anything else that we have in here. No. Okay, what we could do is fix that though. So let's go to debug. As a matter of fact, we're going to change the toml file and add this as a dev dependency instead, right? So where are debug in the grand scheme of things? Okay, so cargo clippy again. Wow, I did... Is it no debug? Yes. Okay, so I might have goofed up. Okay, I guess we don't need... Well, we do need that. Now, how do we do this one? Whoops. We don't want that though. But that is not the issue. The issue is that we need to add this as a feature for a dev dependency, right? Okay, we got 26 matches. Can you show me where? Nope, don't want that. Features. Maybe here. You can add dev dependencies to your cargo whose format is equivalent to dependencies. Dev dependencies are not used when compiling a package for building, but are used for compiling test examples and benchmarks. These dependencies are not propagated to other packages, which depends on this package. You can also have target-specific development dependencies by using dev dependency in the target section. Yes, but what about features? Right? Choosing features. Maybe. The reason that branch exists is because people who have contributed to this project have had their code stolen by me through a bad faith move I did. That is a joke. I made a mistake and I moved code instead of merging, and that resulted in my name getting associated with all of that. Now, I asked people if they cared, if I should go in and fix that, and they said, no, we don't care. But I thought that maybe I'll leave that branch in there anyway for a while. So there's evidence of me stealing other people's code, or rather taking credit for other people's work. That's what I mean. If you never committed to the state change branch, you are not in any risk, right? Now, what about dev dependencies here, right? Where are whoops, dev, whoops. Oh no, I goofed up. Okay, so what about features in dev dependencies, right? Okay, Rust features for dev dependencies, maybe. Did you get it to work? No, there was, I think it's Dottie, Skylar, and Museum that might have committed to that one. No, probably not Dottie. Dottie has committed to the dev branch, but the state change branch was Skylar and Museum, I think. Maybe Dottie as well. Wait, this isn't helpful. Okay. Yeah, that's another mail that the build has failed. Okay, that's stupid. Well, I shouldn't say that. That's probably not been. Maybe has this been updated or not? Yeah, it didn't have anything anyway. I asked him if he cared about the fact that I stole his code, and he didn't. He said it wasn't important to him to get credit for it. But I think it's worth having like a record at least for a while, so it's like obvious that people have contributed to it. All right, so I'm not finding the answer here. Let's try AI then, right? So let's go to duck.ai, and then we say, how do you in cargo using Rust as one does specify features for dev dependencies? Please be succinct and avoid making stuff up. Yeah, I mean, I got what I asked for. I should have taken a second longer to understand what it is that I wanted to ask for. So should we make this workspace dependent, and that's how we do this? You see, it makes us all look bad. But he's currently on some kind of crusade fighting the lemmings, so I don't know what he's doing these days, right? But yes, I'm interested to see what his next thing's gonna be. He's working on synthesizer now, right? It's Rust. The higher plane of existence. Okay, what was I doing? So if we have a feature enabled, it should include a dev dependency. That makes no sense. Well, I guess we don't really need that. We can take this out for now. Oh yeah. Test duties. Oh, beans. Okay, so test duties obviously. Test duties, cargo tomo. Yeah, hang on. Why is that a problem? No matching package found. And then it searches one thing. But it's not required though, right? We took that out. Okay, we'll take that out too for now. Oh yeah. What's requiring this? Oh, a lot of things is requiring that. That could be a workspace dependency as well, couldn't it? Okay, let's edit back in and we just make it into our no-op for now. So you're in there. Where are the rest of the dependencies? Workspace dependency. Okay, let's see what we actually run for. That was a stupid question. Let's just completely pretend I didn't say that. Let's go up to see what we're actually running here. Cargo text workspace, all features. That's why. That's probably why it's griping at me. Because all features would enable the debug stuff. All right. Okay, so there we go. But there is something else that's wrong here. It's the linting as well, which is probably cargo format. Yeah. So somehow I bungle this one too. Okay, but that's easy. We just run this and it's good, right? But now we're gonna amend this current commit and then we do git push and then we do the magical force thing, which makes everything better. But since we have git push force in our history, we don't want that. So we're gonna clear our history and make sure that we don't accidentally do that again, right? And then we can go and see if I broke the build again, right? If I was paid to be a programmer right now, then this would be my coffee break. How you guys doing? No, the path isn't wrong. I expressed poorly what it was that I wanted to do. What does it say? Remove layout filter. Oh yeah, we're supposed to remove the layout filter before we do anything else. But we could technically merge with main for this, right? One cover for each broken build. No, but when you do something like this, rather than sit here and watch the spinner, because that's boring, you go and make yourself a cup of tea or whatever. Already had my daily coffee, so I can't do much about that. But, you know, I can check my phone. Gasp. You have 0 friends. All right, cool. Well, it is doing something and it hasn't failed already. So maybe we can look at the test runner and see. No, that shows that it's failed. Did it fail? That looks like the old test. I think maybe. Oh, wait, what? I just don't trust GitHub. I don't understand why. I will show you something, right? This is pretty awful, okay? When you're navigating GitHub. Look how long it takes to open these things, right? All right, now it's actually reasonably snappy. But if you were to if you were to disable JavaScript here, it generally tends to be a lot faster than if you don't. I clicked on the wrong directory, not that it really matters, right? But this stuff tends to be faster if you disable it, but not always, right? Not always. It has been days when it's so painfully slow that I will disable JavaScript just to be able to click around this thing, right? But ¿qué más importante? ¿Qué es esto? Right? Why is this happening? Why is the build broken? I thought I fixed it. Okay, the tester passed it. Well, I thought we fixed the lint as well. So why is the lint broken? Yeah, I'm not talking about the chocolate. Well, that looks like a clippy lint. Whoops, say it, don't spray it. Default testing. Default widgets testing 258. Cargo clippy. Test. How are we running Clippy? All right, because they seem to be doing Clippy on everything. All features, all targets. Didn't I just do this? And it seemed reasonably happy with everything. Apparently not. Okay, let's go and change this. Testing 159. It makes sense, right? Whoops, no, that doesn't make sense. Where's the issue? Cargo, you know what? We just do this. And then we'll fix you. We'll fix you. Okay, so testing 221. Okay, there we go, right? Nope, that's also not it. Default widget source testing 221. That is not even the same thing. Am I looking at the wrong test? Lint. But this is very confusing. All right, now hang on. I am misreading everything. All right, 258. I was looking for this code on this line, and that does not make sense. Are you a mutable reference? You are. Oh, so it will auto dereference this thing. That's why. Deref will be done by auto deref. Yep. I am old and forgetful. 220. Yep, that's another reference. Main into 159. All right, there's another into the has been something is nothing these days. Whoops. Oh no, you lied to me. Or not. Back to testing 258. Is this not? No, you didn't lie to me. I lied to myself. All right, git add everything. Git commit. No. Git yes commit. Amend. Git push force and history clear. So we don't accidentally git push force anything, right? And then we reload this page 5 times. Always 5. Cash is a hell of a drug. Thank you, Melenth. It's very kind of you. I'm loving streaming these days. It's been kind of, and not just because people are being lovely and nice, right? But it's like for a while, it was such a like drudgery to go through streaming. But and it doesn't hurt that we had this insane sub thing happening, of course. But anyway, shut me up. We got a green tick, which means that we can now merge this into main. Let's see what that would look like if we were to merge dev into main. Alpha to beta, right? Let's look at the pull request. Does anyone want to review the changes, right? There are so many changes. There's okay, GitHub is not even keeping up. There are that many changes. But we can do the merge now. I am really happy about that. There was a couple of to-dos in there and a couple of unwraps that we should get rid of, but we can start with the you know what? I need to start working on an example, right? That is true, Temporus. That is true. For those of you who are new to the stream, my toilet exploded. Not like in a cool explosion that would be in a movie, more like in a I'm a toilet, I'm also hungover, and this is happening now. And it just destroyed my floor, and I just had a new floor put in. And this time I'm gonna do it myself because I don't wanna wait and mess around with that, right? Well, we need a bunch of things. I have a pull request here, by the way. So GitHub. No, wait. I have to write the bot. All right. Wow. There is no shortage of things to do. I have so many things to do, and most of them are fun. All right. Let's see where we're at with the bot. Okay. But this thing is broken somewhere. Okay, there is no chat from the bunny bot. All right, we'll take you out then. What is this supposed to do? It's supposed to send a chat message. Right. So we needed a new method to chat, and I think the bunny bot has that in the chat function. Yeah, chat in the chat library, which just has a send function now, which needs that. There's not even an agent here. It's just a straight up send. The config. I think that might not be right. Yeah, sorry, the random code doesn't work until the bot is up again. But I am so hungry, and it's almost dinner time, and I haven't had any lunch. So I'm gonna go and eat some food. You guys have been absolutely lovely. It has been a great stream. We got so much done. We can maybe merge this into main shortly. And I have a lot of thank you, Caleb. We raid. Who do we raid? Do we raid someone? We could raid. We could raid Cake. We could raid someone new, maybe. Who do we? Wait, why does Prime only have 500 viewers? This is we must help out. Okay, poor guy barely has any views. I bet he's been on for like 10 minutes. 7 minutes. All right. We'll mute that. And we'll raid. Not Prime. Why not? He only has a fraction of what he normally has user-wise. So I think we should give him a raid, okay? I will be back tomorrow, you lovely people. And we're going to implement the bot then, right? Get that working. Get a channel pointer and get an actual 2 up here. You guys have been great. It's been fun. I hope to see most of you tomorrow. Enjoy the rest of your day. Bye for now. Where's this button?